everyone, it's Colt. Welcome to my JavaScript for Beginners course, free course on YouTube. It's a pretty long video, honestly. I was hoping to make a nice learn JavaScript in 1 hour or learn JavaScript in 30 minutes video to keep up with all my clickbaity competitors on YouTube, but those are all lies. This video would be a lie if I told you you would learn JavaScript in 2 or 2.5 hours. That would be a lie as well. What I am going to do is give you a solid foundation in JavaScript. We're going to cover all of the basics that you have to know, the essentials, so that you can move on and fully learn JavaScript eventually. But I have JavaScript courses that are 35, 40 hours of just JavaScript. So saying learn JavaScript in 1 hour or 2 is just completely disingenuous, but it probably gets a lot of clicks. So, probably worth it for them. All right, so before we get started, first of all, if you are new here, please consider subscribing. Take a look at some of my previous videos. Also, if you are looking to change careers or become a software engineer, take a look at my online job-guaranteed software engineering bootcamp. It's very low risk. If you don't get a job at the end, you don't pay anything. You get your money back. It's something I'm really, really excited about. I spent a ton of time working on this. Amazing curriculum, tons of projects. You're paired with your own one-on-one mentor. I'll actually be posting an interview I recorded with one of our mentors who works at Amazon. He's just one of the many mentors that you could have personally answering your questions if you enroll. Anyway, take a look if you're interested in changing careers. There's also a prep course if you're not quite ready to apply. So no pressure there. Now, let's move on with JavaScript. I'm not going to spend any time talking about why you should learn JavaScript, why people are excited about it. There are many great videos on that topic. I just want to focus on JavaScript and actually learning the syntax. So let's go. All right, so the first thing we need to talk about here are the basic primitive types in JavaScript. These are the sort of the smallest things, the atoms of JavaScript that everything else is made up of. So we have number, string, Boolean, null, and undefined. There are technically 2 others. We really don't need to care about them at all, and most people don't worry about them. Symbol and big int. So if you think about these different data types, they're used all over the place. There are different types of information we need to store or represent, not just in JavaScript, but that's what we're talking about here. So we've got a little form, and if you were to imagine trying to store the underlying information that a user enters, we would need a couple different types of data. We have a number here, a number of stars from 1 to 5. We have some text information. We have some more text, a name, an email, and then we have a check mark, a yes or no, a Boolean value. So just a couple of examples, a number, some text, and a Boolean. So the way that I'll be running code at the beginning here is just using the Chrome Developer Console. If you're not using Chrome, I recommend you use it, although you can use the Developer Console in Safari or Firefox, but I would recommend Chrome. You can also run the code in a whole bunch of other ways, but I'm just going to go with Chrome for now, just to keep things simple. So I've got a new Chrome window open here, and to open up the console, there's a couple different ways. I usually use the shortcut. On a Mac, it's Command-Option-J. That takes me to the console, and I can start typing JavaScript, in this case an error. I hit enter, and I see the results. Another option is to go to View, Developer, JavaScript Console. And if you're on a different machine, a non-Mac machine, you'll see the shortcut there. It's probably, Control Option J? I don't know. It's been a while since I used a PC. Anyway, another option that some people like is to go to Inspect. If you right-click, Inspect, and then go to the Console tab, there is where we can type some JavaScript. So we can make this larger that way, or I can pop this out into its own thing, which is what I'm going to do because we don't really care about anything else right now. So the first type we'll take a look at is number. It's pretty self-explanatory. Numbers in JavaScript are numbers. There's only one number type. Other languages, if you have any experience with them, often will have at least 2 different numeric types. One for a floating point number, something with a decimal, versus integers, which are whole numbers. In JavaScript, there's just one number type. It stores positive, negative numbers, whole numbers, integers, or decimal numbers. They're all treated the same. You can see some examples over here on the left. You could just type a number if you wanted to into the console, and JavaScript tells you that's okay, compared to something like this, where we get an error. It's completely invalid. So we've got numbers, negative numbers, fractional numbers, or floating point decimal numbers. Obviously, I shouldn't say obviously. If you're new to programming, there is a limit on precision. So if we have a whole bunch of numbers here, you can see at some point JavaScript is unable to continue storing every single number. Same thing with a very large number. At some point, it starts to lose accuracy. Let's put it that way. Simply typing numbers into a console and getting them repeated back to you is not that useful. Fortunately, we do have some simple mathematic operations that we can do. Things like addition and subtraction, multiplication and division, just regular old math, nothing crazy. So we can do things like 45 plus 9, get 54. 9 times 9 gives us 81. 7 minus, 30. Whoops, syntax error there. Can't have that period. 7 minus 30 gives us negative 23. We also have some operations that you may not be as familiar with, including modulo, also known as the remainder operator. It's really not that important right now, but I hate when people say that in programming videos. It's just not that important, to be honest. Anyway, it works by dividing this number by the second number. So how many times does 2 go into 27? We don't care. What we care about is the remainder. There is 1 left over. So how many times does 2 go in evenly? What is that? It goes in 13 times, and then there's a remainder of 1, 26, 27. There's a remainder of 1. This is sometimes used, or pretty frequently used, to calculate if a number is even or odd. If you have some mystery number, let's just say it's 7. It's not a mystery anymore. And if we modulo by 2, mod by 2, if we get 1 as our answer, we know a number is odd, and if we get 0, we know that it's even. So if I had 8 or 90 or 100, those are all even numbers. 2 goes in to whatever this number is with a remainder of 0. It goes in evenly versus 103. There's a remainder of 1. So that's modulo. And one other operation I'll show you that I didn't put on this slide is the exponentiation, where I can do something like 2 to the second power to get 4, or 2 to the fifth power to get 32. It's just, 2 times 2 times 2 times 2 and so on. So that is sometimes useful. If you want to square something, you could do that, although it's probably easier just to do 9 times 9. But if you want to cube something, you can raise it to the third power. So it's 2 stars next to each other. And you can also see in these slides, I have comments. Comments are created with 2 forward slashes, and a comment is just a way of writing a note, writing some code that won't actually be evaluated as code. So you can write, English or whatever language notes here, reminders. You can put whatever you want in there, and it won't be treated as actual code. So I can type something in there that normally would give me an error, and it's completely ignored. Typically, though, you wouldn't do this in the console. You would be doing this in a real JavaScript file with a whole bunch of code where you want to give yourself some notes or some help for your future self down the line. While we're on the topic of numbers, there is a special numeric value in JavaScript called NaN, or not a number, or non-nan. I just say not a number. And it is a numeric value, so it's treated as a number, but it represents something that is not a number or cannot be represented as a number in JavaScript. So one of the ways we arrive at not a number is dividing something by 0. So 0 divided by 0, or trying to do math with not a number will also give us not a number. It's kind of an interesting topic, but we don't have time to go into it, and it's really just something that you'll run into occasionally if you're doing something wonky with math. 0 divided by 0 gives us not a number. Once we talk about strings, if you try and divide a string by a number, some text by some number, JavaScript doesn't know what to do with that, so it tells you the answer is not a number. There's also infinity and negative infinity. 2 divided by 0 gives me infinity. Negative 2 divided by 0 gives me negative infinity. Not that common to work with them, but you should know they exist. So now let's do a quick little quiz. This one hopefully is simple enough. What does this evaluate to? Nothing crazy here, hopefully. Really just testing math. So this is going to be 1.5 times 2. That will run first because of the order of operations, which JavaScript respects or obeys. So that gives us 3 plus 1.5. That should be 4.5. Here's one more. What does this give us? All right. And here's the answer. We have on the left-hand side in parentheses 10 mod 6. What we just learned about modulo, it's the remainder operator. How many times does 6 go into 10? 1 time. What is the remainder? 4. So the answer here is 4 on the left side. And then we are starring it. That is the exponentiation operator. So we're raising 4 to the second power, which is going to be 4 times 4, which is, 16. So I think that's the answer. And indeed it is. Okay. So while we can use JavaScript as a glorified calculator to add and divide and all of that, there's obviously a lot more that we can do. And the first new concept we'll introduce are variables. So variables, like pretty much everything we're going to cover in this video, are not specific to JavaScript. If you're new to programming, things like variables exist across pretty much every language out there. So a variable is a way to store a value and give it a name. You can see on this little slide here, I like to imagine it as a jar that has a label on it, and then something in that jar, some value. So in this case, we have a variable called age set to the number 72. So we could recall this value at any point. I could say, JavaScript, what is the value of age? Or I would like to add 1 to the value of age because it's a birthday, or my birthday today. There's a lot that we can do with variables, and they're essential to really building anything useful. So the actual syntax to write or to create a variable looks like this. Let, that's a keyword there, so it's always let, and then some variable name, equal sign, and then some value. So here's a very simple example. Let age equals 55. JavaScript, please make me a variable called age, give it the value of 55. Here's another example. I'm making 2 variables, hens and roosters. Notice the semicolons there. That's a larger topic in JavaScript as to whether you need them or not, or when you need them or not. All that I'll say about it for now is that JavaScript will actually automatically insert semicolons behind the scenes if you are lazy and you don't put them after a line. But in the case of variable declarations, what we have here, we should add a semicolon. It's just better to be explicit. So let hens equals 4. That's the number of hens, I guess. Let roosters equals 2. And then at any point, I can recall hens or roosters, or both of them together. I can sum them, and I would get 6. So it's just a label for some value. So let's try making our own here in the console. Let's create a variable to store, the age of my dog. And we need to start with let. Typically in JavaScript, or conventionally in JavaScript, we go with a camel case variable name. So that would mean something like dog age. So we have age, A, and age is uppercase, but everything else is lowercase. Or, num of chickens. It really doesn't matter to the language, but you won't really see anything other than this. Camel case, except for the very first letter, is lowercase. Anyway, let's go with dog years or dog age, and we'll set that to be 8 years old. So I have a dog that is 8 years old, and I hit enter. Now I can ask for dog age at any point, and JavaScript tells me, I know that, it's 8. If I misspell it or capitalize it incorrectly, I will get an error. Dog age is not defined, so capitalization definitely matters, as does spelling. Now, if I did something like dog age times, this is probably all BS, but growing up, I was told it was 7 years, I think, to go from 1 dog year to a human year. So multiplied by 7, this dog is allegedly the equivalent of 56 human years old. Now, what is the value of dog age after this? I have not changed it at all. All that I've done is ask for the value and multiplied it by 7, but that value is still the same in memory. Now I could save a new variable. I could do something like let new age equals, and then dog age times 7. And now I have a variable, new age, that has 56 in it. I could also do things like take dog age, and let's say my dog had a birthday. I could say dog age now equals the current dog age plus 1. And now I'm saying whatever the current age is, which is, 8, add 1 to that, so that's 9, and set that to be dog age. And there's actually a shortcut syntax to do things like this. I can say dog age plus equals 1, or plus equals 5. This is the same as saying dog age equals the current dog age plus 5. So if I did this, the new value for dog age would be 14. And you can see that here, it's stored as 14. There are a whole bunch of other variants. I can do things like star equals 2, and that is going to be the same as dog age equals dog age times 2. So now it's 28. Okay, so that is one way of making a variable in JavaScript, the let keyword. We also have another keyword called const, which stands for constant. It's basically the same pattern that we follow. Let hens equals 4 versus const hens equals 4, but the major difference here is that with a constant variable declared with a const keyword, that value cannot be changed. It is set in stone. It is a constant. So I can do something like const age equals 17, but I cannot reset age to be some new number. There are some other distinctions. Not going to go into it here. I have like a 10 or 15 minute video just talking about let versus const. I'm going to clear the console, just Command K here. Probably Control K if you're on a PC or Windows machine. I'm not sure. If I make a variable with const, how about, well, I guess I should show this. If I try and do const dog age and set that equal to something, it's going to complain to me that we've already created a variable called dog age. So it's important to understand that. We can't have variables created with let and const using the exact same identifier, the same name. So why don't we do something else? How about const, I don't know, year equals 2020. Okay, so I made a variable with const. It works the same way, or it seems to work the same way. But if I try and change year plus equals 1, I get an error. I cannot assign to a constant variable. But if I had used let, that is not a problem. So it seems like const is rather limited in its utility, but that's actually not the case. Later on, you'll see that you use const frequently with things like arrays and objects, something we have not covered yet. Also, if you had some value that you know should not change, the number of days in a week, the value of pi, minimum height for some ride, 60 inches, if these values aren't supposed to change, then you can use const to declare them. Also, there's an older way of declaring a variable. Previously in JavaScript, we only had one option, which is the var keyword, var, same pattern as let and const. But these days, because let and const are sort of newer and better versions of var, almost nobody uses var. I can't think of a good reason you should use var, but you should know it exists. If you see old tutorials or videos, you may see var used. But let and const are replacements. And again, there are some important distinctions as to why let and const were proposed and added into JavaScript over var, but we're not going to get into that here. So quick quiz. What is the value of the egg count variable here after the second line of code runs? And the answer is it does not change. It starts as 42, and then we retrieve the value and add 2, but we're not adding 2 to the variable itself. So the second line is going to tell us 44. It's going to give us the number 44, but egg count is unchanged. And here's one more. What is the value of rating after this line of code runs? Const rating is 7.5. Rating equals 8. Can't do that. It's declared with const. That is a big no-no, and JavaScript is going to yell at you. So the value of rating is unchanged. It stays 7.5. All right, so returning to this slide here with the different primitive types, so far we've only covered number. Now we're going to talk about some of these other types. First of all, a nice and easy one, Booleans. Boolean values are very simple. There are only 2 possible options, true or false. They are just a black or white, yes or no, 1 or 0 value. That is it. There is no nuance there. It's either yes or no, true or false. And specifically, we spell true or false this way, all lowercase. Some other languages will have an uppercase T for a Boolean value true or an uppercase F. But in JavaScript, true and false are very special keywords. They are Boolean values. So we can create a variable and store a Boolean in there. Is logged in equals true. Game over equals false, is water wet equals true. It's relatively simple, especially compared to numbers. But if we just create a quick variable here, a Boolean, how about let is purple great color? That is true. Purple's a great color. There we go. True. So if I type the word true in JavaScript, I don't get an error. But if I spelled it with a capital T, we do get an error. JavaScript does not know what I'm talking about. But true and false, all lowercase, are important Boolean values. Also, you should know that variables can change type. In some languages, this is not really an option, but in JavaScript it is. So if I'm storing something like is purple great color, and it's set to the value true, the Boolean value, for some reason if I wanted to, I could set it to be the number 7. That is not a problem in JavaScript. It is a problem, I guess, logically. It makes no sense whatsoever to have is purple great color set to 7, but we can in JavaScript. Moving on to our next data type, a really important one, the string. So strings are pieces of text strings of characters, and we always wrap them in quotation marks. Now these can be single quotes or double quotes, but you need to make sure that whatever you start with, if it's a double quote, you end with that. If it's a single quote, you end with a single quote. If you mix them up, you will have a bad time. So you just need to be consistent, and let me just show you a couple of quick examples here. I could make, a variable called first name. I'll use const and set it equal to, how about Thomas? I can use single quotes, and there we go. I now have first name set to Thomas. Again, the quotation marks don't actually matter. You just need to be consistent. I'll do another variable, this time with let. Let's do let color equals, and I'll do double quotes, purple. Notice I forgot the semicolon. That was unintentional, but it doesn't actually matter. JavaScript, well, in the console, it's extra easy. It doesn't really matter. But anyway, there should have been one there to be super precise. Color is now set to purple. Okay. We could also have spaces, and how about let phrase equals the early bird gets the worm. That's also a string. Now, there's quite a bit that we could talk about with strings. I'm just going to give you a crash course in them. Let me just show you what happens if you tried to do something like let message with a single quote and then a double quote. We get a syntax error. It is not happy with us. Strings are an indexed type in JavaScript, which means that every character in a string has a corresponding index, basically a positional number, a number that corresponds to its position in the string, and those numbers start at 0. So, as you can see in this string, chicken, C has an index of 0, K has an index of 4, they all go in a row. It's just a way of referencing each character. And I can access one character at a time if I want to using square brackets and then some index inside those brackets. So if I wanted to know, how about our color variable right there? If I wanted to know the very first letter of color, I could ask for color of 0 and get the character P. I'm not changing the string in any way. I'm just accessing one tiny character, the first character. I could also access the second character with index of 1. That's all I'll show about that for now. Also, strings have a length property. So every string, we haven't talked about the term property, but every string has this thing called length. We access it using dots and then length. And you can see that length is set to 6. There are 6 characters, 1, 2, 3, 4, 5, 6. If I look at my phrase variable, let me clear this. Phrase.length gives me 28. Also, this is an accidental space, but JavaScript ignored it here. I would definitely not put a space there on purpose. So 28 characters in that string. Now, if we go back to color and we look at the length, it's 6, if I can type that correctly. But that does not mean that there is a character at the index of 6. I get this other value we have not yet covered called undefined. There's nothing there. Because our indexes or indices start at 0, they go from 0 up until 5 in this case. So the last character in color, this E, has an index of 5, right? I could access it with color square bracket 5. Okay, so every string that we make in JavaScript comes with a set of built-in methods. Methods are basically actions that can be performed on or using some particular string. So these include things like searching within a string or changing the casing, upper or lowercase, replacing parts of a string, repeating a string. There are many different things we can do. I'll just show you a couple. But the syntax for all of them is very, very similar. We have some string or some thing, dot, and then the name of a method, and then opening and closing parentheses. So for example, there are 2 built-in methods that every string has access to, called toUpperCase and toLowerCase. These have to do with changing the capitalization of a string. So over here, I have a new variable called message, MSG. It's set to get out of my room, mom, and it's all in lowercase. Let's add a comma in there. Now, if I called message dot toUpperCase, and this also has to be capitalized correctly. It's not toUpperCase with a lowercase u. It's not all uppercase. It's camel-cased. And if I just hit enter now, I'm not going to really get any results because I'm not executing the code. Remember what we talked about. We need those parentheses. So here, JavaScript tells me, yes, I know about that thing, toUpperCase, but it's not actually executing it. I need to add those parentheses in order to run that method. And this is what we get back. Get out of my room, mom, in all caps. Now, it's also important to understand that message is completely unchanged. This method is going to take the value of that string and make a copy of it that is all uppercased, but it does not update the value of message itself. Now, I could do that. I could do message equals message dot to uppercase, or I might do something like let yell equals message dot to uppercase. And if we look at yell, it now says get out of my room, mom, in all caps, but message is unchanged. So we also have two lowercase, so I could do yell dot to lowercase. By the way, in the Chrome console and in most editors, if you hit tab for autocomplete, it makes things a lot quicker. Yell dot to lowercase, get out of my room, mom, we're back to lowercase. Okay, so there are many other string methods. If I just type some string here, how about LOL, LOL, and then I add a bunch of space, you'll see why in just a moment. And then I type a period to trigger Chrome's autocomplete of methods. All of these methods that we call start with period, or they don't really start with period, but we use the period, a dot, then the name of the method to access a method on a particular string. So when I type a period here, I can see we have methods like to uppercase and to lowercase that we just talked about. But we also have things like one called trim, which I don't really use very often, but if I add those parentheses, you'll see that it trims off the space at the beginning and end of the string. But it does not change any internal spacing. So this can be used sometimes to clean up an input, something coming from, I don't know, a form or something where users are inputting information, and they might have additional spaces on either end. Anyway, there's a lot of string methods. It's not essential enough for us to spend a lot of time on them. But what I do want to talk about here is this pattern where we have something, so far just strings, and then a method name, and then parentheses, and then something inside the parentheses, something we call arguments. So arguments are pieces of data that we can pass to a method to modify the behavior or just to provide some information to that method. So we pass them inside of parentheses, and a lot of the built-in string methods accept arguments. For example, there's one called index of, which will tell us the index of some string within another string, if it exists. So in this case, I have a string TV show, and it's set to cat dog. And then I'm calling index of on TV show, and I pass in cat, C-A-T. I'm asking where does this particular thing, this argument, where does it occur in TV show? And the answer I get is index of 0. It starts right there, index of 0 at that C. If I did dog, we get index of 3, 0, 1, 2, 3. And if something is not found in a string, then we get -1. So I'm not showing this right now because you'll need to know index of, although it's good to know. I'm showing it more to illustrate this concept of arguments, of passing in some values to a method. So here's another example. This is called slice. There's more to slice because we can actually pass in more than one argument. What slice will do is basically make a copy of a portion of a string. So here I've got this very long string, supercalifragilisticexpialidocious, set to the variable name str. When I call slice on it, str.slice, I can pass in one number, like I'm doing on the bottom here. And if I only pass in one number, it is going to make a slice of a string starting at that index. So if I have something simple, how about ABCDEFG dot slice, and then I pass in an index here like 3. You can see, even before I hit enter, what I'm getting, DEFG. So if we count the indices, 0, 1, 2, 3. It goes from 3 to the end of the string. But if I pass in more than one number, for example 3, 5, I'm going from index of 3 up until index of 5, DE. If I did 3 to 6, DEF. So I'm making a new string. I'm not manipulating or changing the original string. So if I had a variable like let phrase equals, do I already have that? Let's see. The early bird gets the worm. And then I call phrase.slice. How about, I don't know, index of 10 to the end? Bird gets the worm. That is what I want to slice. I am not changing phrase in any way. Like we've seen with 2 uppercase and 2 lowercase, I'm simply making a new string based off of that one. But I could capture that into a variable. I can recall that line with the up arrow in Chrome, and then I could save that into a variable, let new phrase equals phrase.slice, and now I have new phrase and phrase. All right, so those are two examples of string methods that accept arguments. Here's one more. This is replace, where we can pass in some string that we're trying to replace within a string. So I'm trying to replace tee-hee within tee-hee so funny tee-hee, and I want to replace it with ha-ha. So it will replace it if it finds tee-hee only the first time. So it's not going to replace this tee-hee over here. Another example I'll show you is repeat. I could have the string ha dot repeats, and I can pass in a number. And this number, this argument here, specifies how many times this string should be repeated. All right, so methods, very important. Strings have lots of built-in methods. And this actually brings up an important point here, which is how do you find these methods, and how would you know what these methods are? Well, the place that I like to go to is a website called MDN, Mozilla Developer Network. It provides some great documentation for things like HTML, CSS, and JavaScript. And I'll show you the homepage here. developer.mozilla.org. I usually just type MDN into Google. And there's a lot of stuff here, but if you go to references and guides, there are some tutorials. If you go to technologies, go to JavaScript, there are more tutorials. But then mostly what I'm really focused on are the standard objects, specifically what we're talking about right now, string. But if we were talking about number, like we did earlier, you can read more about number here. Or Boolean, you can learn more there. But let's look at string. On the left-hand side here, you're going to see a bunch of different methods. These are methods that we have on every single string, although some of them have a little down, a thumbs down. This indicates that you shouldn't use them anymore. They're basically deprecated. They're not encouraged, and not all browsers support them. But even if we ignore those, there are quite a few different methods, and we only covered 2 or 3 or maybe like 5 of them. If you wanted to learn more about them, pick one. Let's go with, how about starts with? And then we have an example of how it works. We have an explanation. It determines whether a string begins with the characters of a specified string, returning true or false as appropriate. Anyway, I'm not really here to show you every single possible method, but this is where you can learn more about them. You definitely do not need to memorize them at this point. Quick quiz here. What would you see if you ran this code in your Chrome console? What is the output? Well, we're asking for index of 7, 0, 1, 2, 3, 4, 5, 6, 7. We would get I, as you can see there. All right, one more. What's the answer here? Index of 3 of pup, P-U-P. Well, 3 letters there, 3 characters, but there's no index of 3. The highest index is 2, 0, 1, 2. So index of 3 gives us undefined, P-U-P of 3, undefined. All right, quick quiz again. What is the value of song after both of these lines have run? So I'll give you a moment, or you really should just pause it, I guess. I'm trying to make this brief. The value of song is unchanged. Song begins as London Calling in lowercase, and then we call song.toUppercase, but it doesn't change song. It's just making an uppercase version, but we're not storing it in a variable. We're just yelling it or whispering it. No, I guess we're yelling if it's too uppercase. We're yelling it into the ether, but we're never capturing that uppercase value. So the next important topic around strings are something called string template literals. And these are actually a newer feature in JavaScript. They've not been around for very long, and we are very happy that they are around. They make our life a lot easier. So template literals are special strings that allow for embedded expressions. Basically, we can add variables or math if you wanted to, any sort of expression that will be evaluated as JavaScript and then turned into a resulting string. So here's a simple example. I counted, and then there's some special syntax, 3 plus 4, sheep. That will be turned into I counted 7 sheep. Seems silly to just write 3 plus 4 when we know ahead of time we could just write 7. But this is very useful when we have some piece of code, some variable, a user's name, or a number of emails in an inbox that we don't know ahead of time, but we want to make some string based off of. Now, syntax-wise, we use backtick characters, not single quotes. So it might look like single quotes, but those are not. They are backticks. We can usually find the backtick key above your tab with the tilde character. They share a key, at least on my keyboard. and you need to use them to indicate that you are writing a template literal. So if I just use a backtick and I write some string hello, it's turned into a regular old string. There's no reason really to do this, but we can. It's another way of declaring a string. But what's fancy and special is that if we add a $sign and then curly braces inside of a string, only a string declared with those backticks, so backtick, backtick, and then $sign curly sign, $sign curly sign, $sign curly braces, whatever code I put inside of here, I could do math, I could do something else, usually not math, but whatever I put in there is going to be evaluated and turned into a string. So if I leave off that $sign, I leave off the curly braces, we just see exactly what we've typed as a string. But if I put $sign, curly braces, that code is now treated as JavaScript to be evaluated as if it's not in a string, and then it's added in. So I can do things like your total is, and then actually add in a total, a very weird total. I don't know why you're dividing by 23, but you get the general idea. So I could have some variable like a username. Let username equals Batman87, sure. And then I could make some new variable. How about a greeting variable, and set it equal to a string template literal, welcome back, comma, and then I can put the username right there. Again, very useful, not in the console like we're doing here, sort of a silly sandboxed, very beginner environment, but in the real world, you have a lot of information that is dynamic, that comes from a variable. It might be coming from a database or somewhere else, and you want to do something with it inside of a string. String template literals make it very easy. So now if I look at greeting, we see welcome back, Batman87. So remember, you've got to use those backticks, not single quotes, not double quotes, but only backticks with $sign curly braces will allow you to embed expressions in a string. All right, so back to this slide of the basic primitive types. We've covered 3 out of 5. The last 2, null and undefined, are much shorter. So I put both of them on the same slide. I'm talking about them together because for a lot of beginners, they can be a little bit confusing. They seem similar, but they are definitely distinct concepts. So null is a particular type, it's a value in JavaScript, that is the intentional absence of a value, and it must be assigned. For example, we could have a variable called logged in user, and if no one is logged in at the beginning, we could set it to null. Instead of setting it to 0 or, I don't know, an empty string or something, which doesn't necessarily make sense, we can set it to be explicitly nothing. It just is a value. Null is a value that represents nothing. There is an absence of a value there. Then we have undefined. Undefined is a bit different. We're not going to assign something to be undefined, at least not usually. Instead, variables that don't have an assigned value will be undefined. For example, if I make a variable color, but I don't give it a value, totally valid, but at the moment there's no value in there, so its value is undefined. Then I can set it to something else. How about, I don't know, electric blue? And then we look at color, it's obviously not undefined anymore. Or another example, we've already seen this as well, is if I did color and then some very high index that we know does not exist, we get undefined. That value is not defined. Versus I could set color to be explicitly null, which I guess would mean there's no color at all, something is colorless, and it is a value that we deliberately use. We set something to null. Undefined is something that typically we get back from JavaScript. It's not something that we set on our own. All right, so that about wraps it up for primitives and variables. Of course, there's a lot more that we could talk about, and yeah, I have courses where we do talk a lot more about those topics, but those are the essentials. That's really the core stuff you need to know on primitives. Next up, we're going to start talking about making decisions in our code. How do we have different outcomes? And the first thing we need to cover are comparison operators. JavaScript comes with more than a couple, 7, 8, I can't count very quickly, a bunch of different comparison operators which allow us to compare one value to a second value, and they all return either true or false, a Boolean value. That's it. There's no in between, there's no gray area, it's either true or false. So you're probably familiar with some of them, greater than and less than. I can just show you that very quickly here. It's easiest if we're working with numbers. So 3 less than 5, that is true. So we get true, the Boolean value true, as the result. If I instead did 3 less than 1, we get false. Right, and then we have greater than. Is 3 greater than 0? Is 3 greater than -1? Yes. We also have greater than and equal, or greater than or equal, rather, and less than or equal to. So we could do things like, is 3 greater than or equal to 4? That's false. 2, that's true. 3 is greater than 2. And 3 is now true as well. 3 is greater than or equal to 3. But if I did 3 greater than 3, we get false. And we also have less than or equal to. And before we go on to the bottom 4, which have to do with equality or non-equality, I want to talk a little bit more about comparisons in using less than, greater than. So far, we've been doing it with numbers, which is definitely the most common. Though you can compare other types, you could compare strings to one another. Just beware that the behavior may not be what you're expecting. The way that it works behind the scenes, very briefly, is that every character has an underlying Unicode value, a number that represents or that corresponds to that character. So this is just a small subsection, but you can see things like uppercase A has a 41, or has the number of 41, and a uppercase B has 42. Simple enough. So we could tell that uppercase A is going to be less than uppercase B, 41 versus 42. But what if I did lowercase a less than uppercase A? A lot of people think that lowercase would come before uppercase. That's not the case. If you look at the chart again, you'll see uppercase A is 41, lowercase a is somewhere on here. I probably already passed it, 61. And there are corresponding numbers, Unicode numbers, for all sorts of characters. So not just the, the Latin alphabets, but also special characters, numbers, accent marks, lots of different marks and identifiers. As you can see here, from different languages, different alphabets, they all have an underlying number, and that number is used to make the comparison. So just keep that in mind. It's not very common that you'll need to compare one sentence to another, but in JavaScript you can, it just may not behave the way you expect. Okay, so now let's talk about equality. We did less than and greater than. When we're checking to see if values are equal to one another, we actually have two different options, double equals and triple equals. This is a very important concept in JavaScript. We'll start with double equals. Double equals, also known as the loose equality operation or operator, checks for equality of value, but not of type. So what this means is that it's going to coerce, it's going to try and take the left and the right and make them the same type, a common type, and then compare them. And this can lead to some unexpected results. So things like 5 equals 5, or a, lowercase a, equals lowercase a. You can see I accidentally typed triple equals because it's so ingrained in me to use that. But if I do double equals, it is true. If I did 1 equals 1, true. And at this point, you might be wondering, why would you do any of this, right? Why would you need to know if 1 is 1? Well, usually we have a variable. We would have some variable like let secret password, and I'm going to type something in here and then clear my screen. And then I could have another variable. We'll call this one guess equals, and maybe our guess will be monkey123. Sure. Okay, and then I could compare. I could attempt to log in. Still very simple, but is guess equal to secret password? Nope, you got it wrong. Very simple logic, but this is the sort of thing that we'll do all the time, or that you'll do all the time in JavaScript, or much more complex than this, but having some sort of logic typically involving variables, values that you don't know ahead of time. Now, if we look at secret password, it's close. Monkeys123, well, I forgot an S, but it wouldn't have mattered because lowercase m, uppercase m, they are not considered the same. Completely different characters. As we saw, they have a different underlying Unicode value. Okay, so double equals works how you would expect it to work a lot of the time, but there are cases like this. 8 double equals the string 8. One of those is a number, another is a string. They are not the same. Yes, they might represent the same concept of 8, but they are different values entirely. But using double equals, they are coerced into the same type and then compared, and we get true. Now, this can be problematic at times, and for the most part, people will tell you to avoid using double equals. just to show you some other examples. If you do something like 0 double equals false, once again, completely different. They're not the same thing, but double equals will tell you that they are. Now, if we use triple equals, which is known as the strict equality operator, it cares about type, not just the equality of value. It's not going to try and coerce the values to be the same type. So if we instead did 8 triple equals the string 8, we get false. Double equals, it's true. Same thing with the 0 double equals false, that's true. But if I add a third equal sign, it is false. So the main takeaway here should be always use triple equals. Maybe there'll be a time down the line, if you have a long and storied JavaScript career, where it might make sense for you to use double equals, but for the most part, stay away from it like it's, I guess, well, I was going to say the plague, but I guess it's a bit of a poor taste phrase these days. Just don't use it. And then we also have non-equality. It's an operation or a comparison that we can check to see if something is not equal to something else. So I'm going to clear this here. I could check if 1 is not equal to 1, and that gives us false because they are equal. So if I did 1 is not equal to 2, now we get true. Now, this version here with a single equal sign is going to coerce types. It's like double equals. So if I did 1, not equal to 1, the string, I get false because it tries to coerce them to the same type. It compares them and it realizes, hey, wait a minute, they are the same, even though they're not the same. But if I did double not equals, we get true. So I pretty much always use this one as well. It's stricter, just like using triple equals. So ignore the existence of not equals and double equals. Just use these guys instead. As this slide hopefully makes clear, go with triple. So we're about to start working with files and actually running our code from an external file instead of just one line at a time in a console. We needed this to get the basics. It's just fast and easy. You don't have to download anything. You don't have to worry about including scripts and setting up an HTML document. All you have to do is write code in the console and hit enter. But we're going to move over to files because usually we want to write multiple lines of code. We might have hundreds of lines or thousands, and we want them to be savable and persist, unlike our console, which just goes away if I close this window. So one thing I want to show you right now while we're here is a particular built-in method in JavaScript called console.log. And it's going to seem kind of useless until we start working in a file. Console.log is going to print some values. Whatever we pass in as arguments, it will print them to the console. So this seems silly because right now I can print something to the console by just typing 1 or whatever I want. It's printed. That's the console. If I call console.log, it is a method, just like a method we call in a string, like to uppercase. I need parentheses. If I leave them off, nothing will happen. I don't run any code. But if I add parentheses and then I add some value in, like 1, it prints it out for me. Now, it is a little bit different. What we're seeing here, without going into too much detail, if I just type the number 1 and hit enter, this is the return value. It's not necessarily printing it. Yes, it is showing up visibly for us, but there is a difference. It's something we'll talk about later when we learn about return values and functions. But for now, it doesn't seem that useful, but I'm just going to show you if you pass in multiple values in here, it doesn't matter what they are as long as they're valid JavaScript, and let's do true as well, they will all be printed to our console. So when we're working in a file, this is really useful, especially when you're starting out, because it's how we can print code from a file into the console. Otherwise, we don't really have a way of seeing a result or understanding what our code is doing. So we need to use console.log. It's equivalent to things like print if you're familiar with Python or other languages. I wish it was just called print in JavaScript, but it's not. It's console.log. It's a method. You need parentheses. You pass in your values you want to be printed. Okay, so next up, let's actually run code from a file. Let's write JavaScript not in the console, but in a file, and run it. Now, the way that we do this is a little bit clunkier than you might expect if you're brand new to this. We don't just make a JavaScript file and click run. We actually have to make an HTML file, and in that HTML file, we include our JavaScript file as a script. Now, if you don't know any HTML, it's not a huge deal. I do have some intro videos for free on YouTube that go over pretty much all of HTML and CSS, but it's not at all necessary for this next step. So the first thing we need to do before we write any code is have a place to write the code. And the editor that I recommend, that I use, and a lot of developers use these days, is called VS Code or Visual Studio Code. It's free. It's really, really good. Lots and lots of amazing features, tons of plugins and extensions, and a big community around it. But you don't have to use it. You can use something like Text Edit if you wanted to, or Notepad. Microsoft Word, I guess theoretically would work too. But usually you'll use something like VS Code or Sublime Text. So all you need to do is click download if you don't have it already, and then open it up, and you'll see something like this. And it probably won't bug you about updating like mine does. So this is an empty editor. We need to make an HTML file as the first thing. So I'm going to right click, or you can go File, New File, or just Command N, New File, and I'm going to name this something.html. I'm going to go with index.html. It's a pretty standard name for an HTML file. I'll make this a bit larger. And because we're not really going to go over HTML here, I'm just going to hit exclamation point tab, and that fills out my basic HTML skeleton for me. Again, not the point of this video. Now I'm going to make a separate JavaScript file, and I'll just call this app.js. You can name it whatever, but it needs to have a .js. And then in here, we'll put a line of code, console.log, hello from your file. Something like that. I mean, you could just do console.log 2 or 1 or x, it doesn't matter, but just something that we'll see in our console. And save this file. And in our index.html, we need to include this script. And the way that we do that is by adding a script tag. Usually I just type script like that and then hit tab, and then set a source attribute to the name of our file. Again, if you're brand new to HTML, don't worry. This is just something you'll do. So script and then src equals quotation marks and then app.js, assuming that that is the name of our script. If you named it something else, make sure that name is here. Alrighty, now we need to open this file in our browser. And we should take a moment to talk about why we have to even do this. Your browser is set up to understand HTML files. It's not set up to understand JavaScript files on their own. So your browser can understand JavaScript, but it needs to be included via an HTML file, which is exactly what we're doing. So our HTML file doesn't really have anything in it. There's not a web page that will be displaying. There won't be any content that we see. It's simply a vehicle to get our browser to run a script. So now we need to open this in our browser. There are many ways of doing this. The simplest is to double click on your index.html if you can find it. So here's my index.html. I'll double click that, and you'll see something like this in your browser. So not much to look at. We don't have any HTML content, but our script should be included. Another way of opening up a file is dragging your HTML file to your browser, or going to File, Open, or Open File, something like that. But I just like to double click the file. And now if I open up my console, this is what I see, hello from your file. Now I might just collapse this back in Chrome just to go on the side, something like that probably. Anyway, we can tell our script is running because we see hello from your file. If you didn't see that, and your code definitely includes something like hello from your file, or you're just console.logging anything, it doesn't matter what it is as long as it's valid in JavaScript, you want to see that here. Now if I change my file, which I just did, I have to save, which I did, and I have to refresh the page. I have to reload and get a new version of that script and have the browser execute it, and it prints out 129 blah 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 blah. Alright, so that's our basic process. We'll write some code in here. I can save it, I can close down my editor, I can come back years later, and then open up my file in the browser and hopefully get some results, at least in the console for now. Eventually, you'll be writing code that changes something that you see in the browser here, maybe makes nice animations, maybe implements a board game, I don't know, live chat, all sorts of different features that are powered by JavaScript written in separate files. All right, so now let's keep learning more JavaScript. We're going to talk about conditional logic. This is how we can actually run different code depending on some sort of condition, on some logic. So the first piece that I'll talk about is the if statement. It's, I guess, relatively similar to English, how we would approach some conditional thing in the real world. If you eat all your vegetables, you can have dessert. I heard that a million times as a kid. Actually, what I usually heard was, if you eat all your vegetables and your two sisters eat all their vegetables, then you can have dessert. It was a horrible tactic my father implemented called team eating. Anyway, long story short, same idea here in code. If something, do this. So we have a variable called rating. Clearly, it is hard-coded. It is set to 3, but imagine this is coming from a database or a user, a form. We don't know what rating is. And if rating is exactly equal to 3, we will console.log, you are a superstar. So if and only if rating is 3. So let's try that out with something else. How about we make a variable called score, like a test score, and we'll set it equal to, how about 91? Sure. Now I'll use I don't know if it's the American grading system or what grading system it is, but letter grades, A, B, C, D, and then for some reason there's no E, and we go right to an F. Anyway, we'll use some of that, and basically if score is greater than 90, we will console.log you got an A on your test or something like that. Okay? So we'll start very simple. If, and then our parentheses, this is the format we always follow. If, parentheses, and then some expression that evaluates to true or false, a Boolean expression, typically involving those operations we've already seen, or the comparisons we've already seen, less than, greater than, that sort of thing. So if score is greater than, we could do greater than 89, or how about greater than or equal to 90, and then curly braces. And those curly braces are very important. Whatever code we put inside of them, whether it's 1 line or 10 lines, will only run if this is true. So in here, I'll just do a console.log, you get an A. And we'll start with that. Let's go to our browser. Remember, I do need to refresh the page. And we see you get an A. Okay, simple enough. Now what if we change score to be 80? We'll refresh the page again. We don't see anything. Okay, so that is our first very tiny decision, tiny little change in our code depending on this one variable that we're hard coding. Yes, simple, nothing crazy, but this format is very, very important. If, some expression in parentheses, and then curly braces. Now, if I have other code after this, something like console.log, you did not get an A, this is not exclusive from this. Both of these could run. In fact, if this one runs, this one will always run afterwards. What I'm trying to say, that was a bit clunky, honestly, is that whatever you have after or before this if doesn't really matter. It's going to run as long as it's not inside of some sort of conditional block. So this might run, and then this will definitely run. Or this might not run, and this will still run. So right now, if I refresh the page, we get you did not get an A. But if I change this back to, how about a 90 this time, we will see you did get an A, and you did not get an A. So these are not exclusive. And that brings us to the next piece I'll introduce of a conditional statement. We have if, and we have an else. Else is basically, if this was not true, I would like you to do this. So if score was not greater than or equal to 90, we will console.log, you did not get an A. You did not get an A. Now only one of these will run. This one or this one. So if this is true, we'll console.log that. If it's not, if this is false, that triggers the else. So with an else, we don't have parentheses, we don't have an expression in there, because it is the last case. It is basically, if nothing before this was true, then run this. So there is no expression we pass in, but we do have curly braces, and then we write as much as we want inside those curly braces, and let's just see what happens. Score is 90, refresh the page, we still see you get an A. Now if score goes to 70 or 80, refresh, we see you did not get an A, and that's the only thing we see. Okay, so that's else. We could make a simple coin toss. Actually, why don't we do that for a moment? I'm going to comment this out. The easiest way to do that in VS Code is to hold or to highlight something and then hold Command/. I believe it's Control/ on a PC. I'm not positive though. Remember, comments are just a way of having our code not run, but leaving something there so we could write notes. But I'm just going to comment it out so it doesn't run. And what we're going to do is print out heads or tails randomly. Now, we haven't really talked about random numbers, so I'll take a moment to show you how you can generate a random number in JavaScript. It's kind of annoying. There's a method called math.random, and it gives you a random decimal number, or random float, between 0 and 1, and it's really long and ugly. I would wish that there was just an easy way to get a random number, like an integer, between 1 and 10, or 1 and 2, or whatever it is. We can do that, but we have to do some additional math. But for us, if we're going to make a coin toss, we just want two random numbers, 1 or 2 or 0 or 1 for heads or tails. What we can actually do instead is just pick a random number like this and then check if that random number is greater than 0.5 or less than 0.5 because it's a random number between 0 and 1. So it's simple enough to do. We will call math.random, save that to a variable. We'll just call this randnum equals math.random. So that will be some random number. This math object, or we haven't talked about objects, but this math thing, by the way, has different methods on it, not just random. It has methods for, what else, for rounding numbers or for flooring numbers and truncating them. There's a bunch of different mathy related methods on this thing called math. But we're just going to use math.random for now. Then we'll write a conditional. Now go ahead and write this out if you'd like to. I would like for you to console.log heads if, let's say, if randnum is less than 0.5. Otherwise, console.log tails. So here's one way of doing it. If randnum is less than 0.5, console.log heads. And then else, console.log tails. Simple enough. Let's see what happens. Refresh the page, and I get heads the first time, then tails, heads, tails, 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 heads, and so on. All right, so another simple enough example of a conditional, if and an else. But we have a third piece that I'll introduce, which is the else if. So else if is a way of adding another condition after your initial if. So if not the first thing, maybe this other thing, or maybe this third thing, or this fourth thing, and then finally the final else at the very end will be a catch-all. So the syntax is else, and then a space, if, and then our parentheses and our curly braces. Let's go back to our original score example. So I'll comment this out. Maybe I'll add a comment here that just says coin toss example. Okay. And then I'm going to uncomment this. You could do it manually by deleting all those slashes or by selecting, and then the same shortcut to toggle the comments on also toggles them off. Command / on a Mac. Okay, so right now it's just if this and then otherwise this. But as we know, there are many other grades. Let's just worry about an A and a B. So if your score is greater than or equal to 90, you get an A. But what if your score is between 80 and 90? It's a B, right? So I could add in an else if, just like this. You don't have to do these on the same line. You can do this instead, else if, and just put each one on its own line. So in here, else if requires parentheses and some sort of expression. Else is just the fallback. It's the very last thing. If nothing above me matched, okay, then do this. But else if has a condition that's required. So else if score is greater than or equal to 80, we will console.log you get a B. Very confusing to have A, B, but you get a B. And remember, this can only ever run, this line right here, if this did not run. So it's going to go in order. It will try this first. Is score greater than or equal to 90? If it is, this runs and we're done. Nothing else runs here. Nothing else in this conditional block at least. Now, if this is false, if score is not greater than or equal to 90, then it will try this. Is score greater than or equal to 80? Yes or no? Well, it depends. Let's say it is. We'll console.log this. If it's not, we console.log this as the fallback. So right now, score is 80. If I refresh the page, you get a B. Now, if I go to a 90 and refresh the page, you get an A. And if I go to a 70, refresh the page, you did not get an A. Well, that's not, I mean, that's true, but it's not very helpful because you also did not get a B. So I could flesh this out a bit more. I can add as many else ifs as I want. So this one will be score greater than or equal to 70, you get a C. And then another one, if it's greater than 60, you get a D. And then else, you get an F. Would it be an F, A, F? Anyway, so let's test it out now. Score will be 70 here. Refresh, you get a C. How about score is now 20? Very low score. I messed that up. That should be you did get, or how about you got an F, or you get an F. Okay, try that again. You get an F. How about 69? You get a D. Oh, geez. It's a little innuendo heavy there. I apologize. That was not intentional. How about 75? You get a C, and we've already seen 85, 90, all that stuff. So we have some very simple logic, just based off of a single score that's hard-coded. We have different outcomes. We try this first. If that is not true, we try this. If that's not true, then how about this one? And then this one. And then eventually, if nothing else was true before, run this line. Or whatever we have in here. Could be multiple lines. Now, I should have semicolons in there. As you've already seen, it doesn't really matter at this point. It's not breaking anything, but it's always good to put them in. You do not want semicolons after curly braces or after a conditional or anything like that. The rules, I'm not going to go through and explain them all at the moment, but I mentioned this earlier that JavaScript will add semicolons in for you when it thinks you need them. Sometimes it can get it wrong and cause problems, but for the most part, it's not a big deal. Over time, you'll learn where they're necessary and when you should add them. Okay, another thing we can do with conditionals is nest them. So we can have one if or an else if or an else, and inside of those curly braces, add a new set, an if, an else if, and an else, and so on. So here's an example. It's slightly more complex than what we've seen so far, where I'm checking to see if some password variable has a length that is greater than or equal to 6. If not, we're going to console.log password too short, but if it does have a length that is long enough for our password, then we're going to check if there's a space in there. I'm using index of string method. We mentioned it briefly. It tells us the index where some string occurs in another string. And if it does not occur, we get -1. So this nested if right here is checking to see if there is a space inside of password. And if there is, we console.log password cannot include spaces. Otherwise, we console.log valid password. So we have one if, and then nested inside a second if. Let me show you another example over here with this silly little score example. Console.log, you get an A. I could add another if inside of here. How about if your score is greater than, what's an A plus? It would be a 98, 99? Let's just say it's a 98, sure. So if score is greater than or equal to 98, I don't know why I added that extra space there. We don't need it. But if it's greater than or equal to 98, we'll console.log extra congrats. You get an A plus. Okay, so we have an if inside of an if. So this will only run if this part is true, and it will only run if this top part is true. So there is a world where we could have something like if 1 equals 1. That's always true. But it's only going to run. This code will only be executed if this conditional, if this if right here expression is true. The code inside those curly braces runs, and then this would run. So nesting does have, it has important consequences. It's very different compared to just putting a conditional outside of a parent conditional. It's a poor way of saying it. But nesting it has consequences. So here, let's see. Oh, well, my score is 85. Let's go with a 99. Refresh the page, and we should see you get an A, and extra congrats, you get an A plus. Nested conditional. So we could also have an else in there, else console.log just a regular A, and refresh, nothing changes. But now if we go with a 95 and refresh, you get an A, just a regular A. All right, so that's the basics of nesting conditionals. You can continue nesting things further and further. Generally, we want to avoid nesting multiple levels deep, past probably 2 levels. It gets a little bit crazy to follow if we had more conditionals and further nested conditionals, but that doesn't mean that we need to limit the sort of logic that we implement. Instead, we can take advantage of logical operators. So we're going to talk about these 3 operators here, and, or, and not. It's a little bit confusing because I have to use the word and there, or and not. But they are 3 separate operators. They may be a little bit foreign to you if you're new to programming. All 3 of these operators operate on expressions. So basically we can join together multiple pieces of logic, or we can negate something to flip it from true to false or false to true. We'll start with and here, which syntactically is represented with 2 ampersands. And for the entire expression to be true, if we have an and operator in the middle, both the left and the right side must be true. So I'm going to show you a very simple example. We'll just start in the console. We won't write any code in our file. Here is one expression we know is true. 1 equals 1. That's true. Okay. 1 equals 1. And here's another expression. On the other side of and, how about 2 is less than 9? Well, I did greater than. I meant to do less than. Okay, so this part is true. And if we put this together with an and in the middle, both the left and the right have to be true for the entire thing to be true. So we see true. But if I change something like greater than, all of a sudden we get false as the end result. Even though this part is true, 1 is equal to 1, that's true. And false. True and false. I could actually just write that out here. True and false gives us false. True and true is the only way we can get true out of this final expression. False and true also gives us false. Both the left and the right must be true. So you might be wondering, why would you use this? Well, in this example here, I'm combining 2 different pieces of logic. One expression on the left and another expression on the right. Both of them have to be true in order for this to happen, in order for console.log valid password to actually be executed. So I'll show you another example over here in our file. I guess I'll comment this out too, and we'll write another example. In this example, we'll have 2 different variables. Let's go with a color. Color will be purple. And another variable will be animal. How about toad? Okay. Then we'll write a simple conditional if color equals purple. And then inside of that, I also want to check if animal is toad. Animal equals toad. If that's the case, both of those are true, then I want to console.log. I don't know, this is so dumb anyways, purple and toad, but I want to console.log, yay, purple toad. Sure. So let's run this very quickly, refresh the page, and we get yay, purple toad. Okay, simple enough. But I don't have to write this as a nested conditional statement. Because of the and logical operator we just covered, I could rewrite this like this. If color equals purple, and 2 ampersands, animal equals toad. Make sure I capitalize things to match what I have. Then we can console.log, yay, purple toad. So I'm combining 2 different pieces of logic, 2 expressions. If this is true, and this thing is true, then we'll print this out. Otherwise, we can console.log something else. Boo. Not purple toad. Sure. Okay, so we should get the same exact result right now, yay, purple toad. But if I change one of them, instead of toad, how about purple frog? Refresh the page. Boo, not purple toad. Both of these had to be true in order for the entire thing to be considered true. So it's nothing groundbreaking. We could write this with multiple conditional statements nested, or we can combine our statements into a single expression like we have here using the and logical operator. We also have the OR operator, which we write using the pipe character, rather two pipe characters, usually found above the enter key or the return key on your keyboard. On my keyboard, I have to hold shift. It shares a key with the backslash. So it's not an L or a 1, it is a pipe character, and we need two of them. So the OR operator only requires one side, the left or the right, to be true in order for the entire thing to be true. So as you can see here, I've got 1 not equal to 1. Well, that's false. On the right, I've got 10 equals 10. Well, that's true. The whole thing is true. Only one side must be true. Here's another example. Let's just do it in the console again. 1 equals 1, or two pipe characters, 1 equals 1. Well, both of those are true. True or true gives us true. Now, if I instead recalled that and had 1 not equals 1, the whole thing is still true because the right side is true. And if I negated this side or I made it false, what if I just wrote false? The whole thing is now false. This is false and this is false. Left and right are false. That's bad. Well, it's not bad, but the overall thing is not going to be true because we're using the OR operator. One side at least has to be true, or both can be true. So I'll show you an example where this can be useful. Let's say that we run a theme park or a theater. Maybe we run a theater. And based off of someone's age, ticket prices change. Let's say we have somebody who is 5 years old. So if age is less than 8, let's say that someone gets in for free. So if age is less than 8, console.log, you get in for free. A lot of theaters and places have free admission for children. And the same is true if you are a senior, in this case, a senior citizen. Let's say you're above 65, 70. Let's do that down here. So we'll do we could just do an else if, I guess, or just a separate if. Let's do an else if age is greater than 75 or 70. Let's do that. Maybe greater than or equal to. We'll just do the same thing. You get in for free. Otherwise, we can console.log. That will be about $10. Okay, so we have two things that have the exact same outcome. You get in for free, but two different pieces of logic. And only one of these is going to be true for a given number, right? We can't have a number that is less than 8 and at the same time greater than or equal to 70. At least not in the mathematics that I know, I guess. I don't know. I shouldn't have said that. I regret this. Let's run this. Age is set to 5. Make sure that we get what we expect. You get in for free. I'll change age now to be 50, and we expect to see that we have to pay $10. And I'll change it to be, 79, if I can type it. Refresh. You get in for free. Now, using the OR operator, the OR logical operator, I can reduce this here down to a single conditional statement, just a single if. If age is less than 8 or age is greater than or equal to 75, is that what I said? I think it was 70. Such a bad memory these days. We'll console.log, you get in for free. So only one of these is going to be true in this case, although if there were a world where both of them were true, it's totally fine. But with OR, we're just saying one of these must be true for the entire thing to be true. Now, if both of them are false, then run this. If we had done and, it's a very different story, as we've seen. Both sides must be true. Okay, so let's just verify it still works. We have 79 as our age. You get in for free. Let's do 6 as our age. We should also get in for free, but if we do 60, that will be $10. Okay, so that is the basic idea behind logical OR. And then finally, we have logical NOT, our third logical operator here. It's written using an exclamation point, and logical NOT will return true if the expression that we're applying it to returns false. So let me show you an example of that. Here's a very simple example. We have the Boolean true. If I use not in front of it, which negates it, it returns false. Now, if I have not false, it returns true. We could also do more complex things like 5 equals 5, triple equals 5, and then I can put parentheses around the entire thing and negate it, and now we get false. That's pretty much all I'll show you for now, but you can apply this to any other logical expression, long or short, complex or simple. It is always going to take some expression, and if that expression evaluates to true, when we negate it with logical not, the whole thing is false, and if the expression returns false, logical not will return true. All right, so next up, let's talk about arrays. In JavaScript, we have access to a built-in data structure called the array. An array is just a collection of values, and those values can be anything. It could be comments of or comments on an Instagram post, or responses to some tweet. Could be a collection of levels, which are very complex levels in some game. So a level needs to include a whole bunch of stuff. It's not as simple as just a string, like a comment. It could be the songs in a playlist. It could be the lineup for Coachella. It's just a collection of values, although I guess the lineup's not necessarily ordered. It kind of is, though. Each line going down, whatever. It's just a collection of values. So here are some examples. We have an array called colors, which is a collection of strings. There's another one called lotto nums, which is a collection of numbers. Notice the syntax for how we make an array. We use these square brackets, opening and closing, and then a comma-separated list of values inside. So whatever those values are, and whatever order they are in, will be used to create an array. So I'm going to clear this. I'll make this a bit larger here. And let's make an array. We can do something easy like nums equals 5, 23, 99, and -1. There is our nums array. We look at it. It has 4 items in it. That's what the console tells us right there. And there's an order. 5 is first, -1 is last. Now I can change that. I can move things. I can reset or update values. But first, let's see that arrays have a length property. Nums.length is 4. Let's make another array. How about hens? Sure. These will be some chickens. We've got, I don't even know, Stevie and Edna, and what's another hen name? Henrietta is a bit, whatever. It's a bit generic for a hen, but sure. Okay, so here's our array of strings this time, and it has a length of 3. So arrays are collections, and they are ordered, and they are indexed, just like strings are, where each element in an array has a corresponding positional number, an index, starting at 0. So if I expand them in the dev tools, again, this is just the dev tools that lets me do this, I can see the index next to each value. So 0 is Stevie, 1 is Edna, 2 is Henrietta. Or with nums, 0 is 5, 1 is 23, and so on. If I wanted to access one of those, let's say hens of index, and before I type this, how about if I did hens of index 2, what would I see if I hit enter? Well, index of 0 is Stevie, 1 is Edna, 2 is Henrietta. And how about nums with index of 4? Here's nums. What would I get if I put index of 4 in? Well, length is 4, but that does not mean there's an index of 4. The greatest index is 3. So we get undefined. There's nothing at 0, 1, 2, 3, 4. There's nothing there. We get undefined. So we can also use this syntax to change a value. If I wanted to, change the first element in hens, I could do hens of 0, that's our first index, our first element, now equals, instead of Stevie, how about we realize that it's a male, it's a rooster. Hens of 0 equals Stephen. Now if we look at hens, Stephen, Edna, Henrietta. So I can change one element at a time using that index notation. Square brackets and the actual numeric index. Here's one more quiz question. What happens if I do hens and then square bracket? Let's say I'm going to take this. How can I hide this so you don't see the answer? Hens of square bracket 1. There we go. Square bracket again 2. What's going to happen here? It's a quiz. Okay. So what does hens of index 1 give us? Well, index of 0 is Stephen. Index of 1 is Edna. But then we have another index of 2. Well, strings like Edna are indexed. So I can access index of 2 of Edna, which is 0, 1, 2 for n. And that's what we should see. Indeed, it is. Okay. Arrays also come with quite a few built-in methods. Here are some of the more common ones, but this is definitely not all of them. I'm going to focus on these four for now. Push, pop, shift, and unshift. They all have to do with adding and removing elements at the beginning or the end of an array. So we'll start with push. Push is a method we call on an array, like hens.push, and it expects us to pass in some value that will be pushed onto the end of hens in this case. So Stephen, Edna, Henrietta, how about Edith? Okay, we look at hens now, and at the very end we have Edith. I could push on again. Let's do one more. How about just a boring hen named Bob? Now we have Bob at the very end. We also have a method called pop, and pop will be used to remove from the end of an array. We don't need to pass anything in. It will do the same thing no matter what. It takes the last element from our array and removes it. And it returns it to us. As you can see here, Bob, if we look at hens, it now does not have Bob. And I could save that to a variable. So I could do something like let this is sad, but I could say let dinner hen equals hens.pop. And that will be taking the last item in our array and saving it into a variable called dinner hen and updating hens to now only have 3 hens or 3 strings in it. So we also have shift and unshift, which operate in the same way, but at the start of an array. So unshift, it's a little bit confusing when you're starting out. You'll probably mix these two up. Unshift adds to the beginning and shift removes from the beginning. So if we try hens.unshift, who should we add in here? How about Norma? Norma. We look at hens. We now have Norma at the beginning, and then we do hens.shift rather. That will remove the first element, which is Norma. We just added her in, and now we're back to 3 elements. So these are really common methods because as we've seen, arrays are ordered. They maintain that order. And often we want to add elements in or remove elements based off of the order. So for example, maybe we have an array that is restaurant orders, a waiting list for people who have, people who are waiting in line to come to our restaurant. We don't have seating ready. So we have our first person who is, how about Harry? And then the next person in line is Jasmine. Okay, sure. So let's call that wait list. Let wait list equals that array. Now to make this a fair wait list, the person who was in the wait list first, which is Harry, will be the first person to be helped. So we could use which method to get Harry out of there. Waitlist dot, and the answer is shift. We get Harry, and now it's just Jasmine. Now if I wanted to maintain this order, how do I add someone into the end? Some new person shows up and wants to get a table, so they put their name down. How would I store them here? Let's say their name is, this is the hardest part, Brian. How do I add Brian in at the end? Well, it is push, not pish, but push. Oh, goodness, twice in a row, huh? Here we go, and then we'll put Brian right there. Waitlist.push. We'll put the next person at the end, so I could push someone else in. I could do, just to show you this, we can have a mixture of values. If I wanted to, I could have numbers in there. I could put a Boolean in there. Weird in this case, but fine. So push will add to the end, and shift removes from the beginning. Now there are these other methods. Concat, includes, index of, join, reverse, slice, splice, sort. We're not going to go over them here. There are many of these, and they're useful. They're very useful. There's actually a bunch more methods we're not going over. Things like map and reduce. There's a reason this YouTube video is not 20-something, 40 hours. But those are essential methods that you should come back, you should circle back to and learn at some point. But just to give you this intro, that's one of the sacrifices we've had to make. I'm sorry, array methods, you are important, just not important enough. Next up, a note about using const and arrays. So as we've seen with const, at least so far, if I make some num, I'll set it equal to 99. If I wanted to change num plus equals 1 or num equals 100, Not allowed at all. I cannot reassign or update the value in a constant, which I've declared using the const keyword. But if I use const to make an array, let's go with colors. Let's just do red, orange, and I don't know, how about teal? I use const here, which you might think means that I cannot change anything about colors, but that's not actually the case. If we look at colors here, it has 3 elements, red, orange, teal. If I push on or use unshift or shift or pop or any of the other methods that change an array, it's allowed, even if I'm using const. So colors.push, how about purple? We look at colors. First of all, we didn't get that scary red error message that we got earlier. It's totally fine. And the reason for this is that when we use const and we set it equal to an array, what is actually being stored and what cannot change is the reference to the array, not the contents. Think of it as an egg carton, I guess, where that egg carton has to be there, but it could have 1 egg or 20 eggs or 50 million eggs. It doesn't really make sense at all. But we can change the contents of that array, but what I cannot do is suddenly say, actually, colors equals a new empty array or a new, how about just a number? I can't do anything like that. I can't reassign it, but I can change the contents of that array. So this is very common to use const with arrays, because usually we don't want to reassign some variable to be a brand new array. We want to keep the same original wrapper, the same container in memory. Now, another thing you should know about arrays, now that we're talking about them, is that comparing them does not work the way you might expect. If I have the array 1, 2, 3, and I do triple equals 1, 2, 3, it is not going to be true. Why not? Each one of these, every time I use square brackets, I'm making a new reference in memory. You can think of it basically as a location in your computer's memory. And that location is unique. So even if the contents are the same, it doesn't matter. Triple equals is not going to look at the contents. It just looks at the places, the locations in memory. So I'll show you another example. If I do const A equals 1, 2, 3, and then const B equals A, they are now references to the same thing in memory. A equals this in memory, and then B equals whatever A is. So it's like 2 arrows pointing to the same thing. We look at A, we look at B, they're the same. And if I change something, how about I push 4 onto A? Let's look at A, let's look at B. Both of them have those changes. And now if I do a triple equals, we get true because they are one reference in memory. So if we do have different arrays that are not the same reference and you want to compare them, it's a little bit trickier. You have to look at the values. You can't just rely on triple or double equals. If I try double equals, empty array equals empty array, it's still false. Triple equals, it's still false. It's comparing the address in memory, which is not, well, it's not quite the address, but it's comparing the reference. Think of it that way. Okay. Another thing that's very common with arrays is to have nested arrays, which are also called multi-dimensional arrays. So here's an example. A pretty common situation where people use nested arrays would be with some sort of game board, like a 2-dimensional game board, a checkers board, a tic-tac-toe board. Let's do just tic-tac-toe, sure. Where you have 3 rows that make up a game board. Or we could do 3 columns. It really depends on how we want to structure this. But imagine we have 3 rows going across. Each has 3 elements in it. So we would have our first row, which maybe has X, X, and then O. And then we could have our second row, which will be O, let's see, X and X. And then our third row, which would be, I'm making this up here, do we have a tic-tac-toe anywhere? X, yeah, that should be a tic-tac-toe, right? If I put an X there. So if I hit enter here, my game board array is now an array of arrays. And it's easier to see how it's a game board. The way it's displayed here, it's exactly the same. This is just the DevTools making it look slightly nicer. So how would I print out this middle X right here? Let's say I wanted to change it to be something else. I decide, actually, that was supposed to be an O. I don't know why, but I want it to be an O. How do I make that an O? Well, it's the same idea as what we saw earlier, where we had a string inside of an array, where we used our first index to unwrap one layer of the onion, that right there, and then our second index inside of that array. So we'll do game board, and do this as an exercise if you'd like. Try and change that x here, the middle x, to be O. So game board of, and then what's this index here? 0, 1. There's only 3 different items, 0, 1, 2. We want index of 1. That gives us the middle array. And then we want the middle index of that, which has an index of 1, 0, 1. And then I'm going to set that equal to something else, an O. And I'll do an uppercase O just so we can see it for sure. We look at our game board now, and we have an uppercase O right there. So long story short, nested arrays are frequently used to make game boards and other data structures. It's a horrible sentence, but they're used a lot in programming. Next up, we move on to a completely different data structure. It's built into JavaScript as well, and it's called the object. Object literals specifically are what we're going to focus on right now. Objects are collections of key value pairs. Each key value pair is what we call a property. So rather than having an ordered collection like an array where we use an index to access elements, give me the 20th element or give me the first element, index of 0. Rather than that, which is an array, with objects, we use key value pairs. As you can see in this little diagram I made on the right, we would say something like, I want age, or set age to 20. What is city, or is admin? What is zip? So key value pairs. A key, which is what's shown on the left, and then a value, which is what we have on the right. They don't have to be strings. It could be numbers, Booleans. It could be an array, another object. We haven't talked about things like functions, but we can put functions in there. There's a lot of stuff that we can do for those values. But let me show you the basic syntax first. I'll clear this, and we'll make our first object. Frequently, more than frequently, most often, you'll use const instead of let. For the same reason that we used const with an array. It allows us to still change the contents of the array or the object, but you can't reassign the variable to a new object or a new array. Okay, so const, let's just go with person, and then curly braces. Curly braces instead of square brackets. So that makes us an empty array. This will make us an empty object. And an object consists of key value pairs, so we have to specify both of them. And the syntax for that looks something like this. Let's go with age will be 19. What else do we have about a person? How about a first name? Will be Archer. Sure. Okay. So you can see already we have key value pairs. They're separated by a comma. And within each key value pair, we have a key and then the colon or a colon and then a value. And notice I'm not putting quotes around age. What is that? If I just, I'll copy this for a second. No, there we go. If I just typed age like this, well, I have a variable called age. That's unfortunate. How about first name? I don't think I have a variable called first name. If I just type that on its own, I get an error. But if I add quotes, it's totally fine. Now, if we go back to this line, what actually happens here is that these keys, age and first name, will be converted into strings for me. This is just a nice shorter syntax. So if I look at my person object now, they don't look like strings, but this is definitely a string, and this is definitely a string. Age, 19, first name, Archer. That is the very, very basics of setting up an object. Now, how do I get information out of an object? All I need to do is access the variable, and then I use square brackets again, which is kind of confusing. But instead of passing in a number like 0, I'm going to pass in a key like age. This is one option. Person, square brackets, age gives me 19. So think of a key as like a physical key to open a lock. You know the thing you're looking for. I'm looking for age. I'm looking for first name. But we don't know the corresponding value. That key hopefully unlocks that value. Let's do person of first name. And we'll get Archer. We also have an alternate syntax, person dot age, where I don't use quotes. I use the dot syntax, and I get 19. Now, you might recognize this from things like length. Length is a property that is added automatically to an array or a string, where I can use that dot property, or dot length, but I can also do this right here, the syntax I just showed you. Okay, now you might be wondering, is a string an object? It looks like we have the same syntax. We're not going to open that can of worms, but that is an interesting topic in JavaScript. Let's ignore it. Why did I even say anything about it? Okay, so yes, you can make an object with curly braces. You can add your key value pairs like this, but what if I want to add something in after the fact? Person needs to have a last name. So I can do that using the same syntax. I can do person dot last name or person square brackets last name equals, and then set it equal to something like, I don't know, would be a last name Archer, I don't know, Sanchez, sure. Now if we look at person, we have age 19, first name Archer, last name Sanchez. Key value pairs. An array, technically, I guess you could think of as key value pairs, where the keys are all numbers. They're all numbers, numeric indices, and they are ordered. In an object, we can use whatever we want as the keys, although they will be turned into a string. So I can illustrate that one more way. If I do person of, I could do person of 100 equals 100 for some reason if I wanted to do that. And then if I access person of 100, we get 100 out. But if I add quotes around that, you'll see that it also works. So I'm turning it to a string now, and it will be compared to 100, the key, which is a string as well. So you can see right here. There it is. Or if I just pass in a number, JavaScript will turn it into a string and look for that key, which is a string. And if it doesn't find it, what do you think I'll get? If I do person of, how about city? Person.city. Well, this was a horrible exercise because you already see the answer. We get undefined. Just like accessing an array or a string of index 100 that does not exist, we get undefined. There is not a value there. It is undefined. So objects are key value pairs. The keys will be turned into strings. Technically, there's something called symbols we're not going to go into. It's another one of those topics I am shelving for now. If you check out, well, I don't want to sell you on anything, but if you do check out my more in-depth JavaScript course, I spend some time talking about symbols and go into a lot of detail. I also have another YouTube video on that, so if you're curious. Anyway, I guess you could say that for pretty much every topic in this short course. You know, arrays, we spent 10 minutes, 15 minutes on. In my JavaScript courses, we spend a couple of hours on them. Okay, so key value pairs, where was I? Totally sidetracking myself here. Right. Keys need to be strings or symbols, and if they are not a string, they will be turned into a string. And values can be anything. So we've only been using strings and Booleans, strings and numbers here. But I could put an array on person. I could say person.friends equals an array. And this could have, I don't know, whatever I wanted in here. I could have Tammy and let's do one more friend. How about Panda? Sure, Tammy and Panda. Now if we look at person, we have a couple of properties. Remember, each one of these pairs is a property. Key value equals property. So we have 100 is a string, 19 a number, and then we have friends, which is an array. The value for friends is an array of 2 items. We can put whatever we want in here. And objects are incredibly common. And what's actually very common is to use objects and arrays together. So this is a simple example. But in the real world, if this was, I don't know, let's say a very horrible social network, the friends array probably would not just be an array of strings. It might be something like this, where it's an array of objects. And each friend has a first name, like Tammy. And then how about an age, like 30, a username, Tam, and so on. And then we would have another object for the next user. So why don't I actually fill this out real quick. We'll have another person. First name will be, what do we have? Panda? Sure. And age will be 73. And what else did we have? Username will be panda man. Okay. Now I'm going to save this to a variable, const friends. Okay. And what I'd like for you to do here, just, you don't have to type anything out, but how about this? I would like for you to average both ages here. Now, this is a bit more complex, so you'll need to, don't just do 30 plus 73 divided by 2. Don't cheat like that. Pretend you don't know what these ages are. And grab them from friends. So how would we access age for this first one and age for the second one? Add them together and then divide. So pause if you'd like to try it or write it down. But it would look something like this. Friends of 0. That gives us the first element in the array. Well, that's just this object. And then within that, I want age. So I can do this, or I can do dot age. And I'll probably just take that and do the same thing. So add that to friends of 1 to give me the next friend, dot age again. We get 103, and then we're supposed to divide by 2. And if I just divide by 2 here, it's not exactly accurate. We want to add parentheses and divide by 2 so that the division happens after we add them together, and we get 51.5. Really, that doesn't matter. The point here is just making sure you can access something from an array and then a property from an object. Now, this data structure is still quite simple for the real world. We would have things probably in here where we might have nested objects and arrays and more objects and so on. Things get quite complex when you're trying to represent, a person is about one of the most complicated things that you could try and represent. But even just a user for, let's say, Instagram, you've got to store friends or followers, and then people, what do you call them? Following versus followers, followees. You've got to store posts and stories and comments and likes and so many different things just for a single post or a single user. You've got tags, people who have been tagged, hashtags, geodata or locations that have been tagged in an image. There's so much going on. But at its core, we could structure just a bunch of arrays and objects together to represent that data. And that's what a lot of programming is, especially in JavaScript. Other languages have different data structures built in and different names. Instead of an object, like in Python, we would use the term a dictionary, but it's the same concept, a key value data store. Anyway, so those are two very essential data structures that build upon other pieces of data types like numbers and Booleans and strings. Data structures like arrays and objects use those smaller pieces, numbers and so on, and store them. They structure them. So next up, we're now going to talk about loops. Loops allow us to repeat things. Whether we are just printing a message out over and over and over, or printing numbers from 1 to 10, really trivial beginner things that nobody really does in the real world, or we are doing something more realistic like looping over an array of comments, and for each comment creating an actual comment in the browser that you can see with HTML and CSS, or for each tweet displaying the tweet image. There are all these things that we do where we run some code maybe 100 times or 1,000 times. So this is where loops come in. Loops allow us to repeat things, and there are multiple types. There are for loops, while loops, for of loops, for in loops. And we're going to begin with the for loop. So the regular old for loop is a little bit intimidating if you're brand new, not because it's complicated or difficult, but the syntax can be hard to remember when you're starting out. So if you see what I've written here, this honestly might just confuse you more. This is the pattern that we follow. For some initial expression with some condition, some increment expression, inside of parentheses. It doesn't seem to make much sense, but I promise you there is a method to this madness. Here is a loop where we have those three pieces, 1, 2, 3, separated by semicolons inside of parentheses. This first thing, what I call the initial expression, is going to run the very, very beginning. It's going to run at the beginning of our loop, where we're making a variable called I, which is relatively standard or conventional. You just want a short variable name. One of the only times, really, I is an acceptable variable name because it's just a placeholder. It's just there for your loop. Anyway, we have an I variable that starts at 1. Then we have what I call the condition. Continue running this loop as long as I is less than or equal to 10. And then each time through the loop, we have our increment expression, I++, which if you're not familiar with, if we have some variable, let I equals 1, if I run I++, we look at I, it's now 2. It's the same as doing I plus equals 1, it's just slightly shorter. So we would read this as, for the variable I starting at 1, add 1 to I each time, as long as I is less than or equal to 10, run this code. Console.log I. So very simple. We're just printing out a variable I. Let me write one of our own over here. Let's make our own for loop. For let, and again, I is pretty standard. Let's start with I at 0. And we'll run this loop while I is less than 10. I++, or we can do plus equals 1, but plus is very common. And then in here, I accidentally deleted my parenthesis there. In here, we can console.log in the loop, and then I'll also print out I, so we can see what that variable is. Now I'm going to refresh my page over here, and we see in the loop 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I started at 0, we printed it out, then I had 1 added to it, and the process starts over. Now I is 1, we print that out. I has 1 added to it, so it's 2, print 2 out, and we keep going as long as I is less than 10. As soon as I is not less than 10, so once this loop runs, the final iteration, I is 9, I has 1 added to it, I++, it becomes 10. This is now false, and the loop finishes. So we could change this up a bit. I could do something like I plus equals 2. Now, what will we see printed out? Take a moment and ask yourself, what numbers will we see printed out? So I begins at 0. We will print out 0. Then we add 2 to I. So the next time through, it's equal to 2, and we print that out. And then we add 2 more, so we get 4 and 6 and 8. And then we add 2 more after we print out in the loop 8. I is now 10. I is not less than 10. 10 is not less than 10. 10 is equal to 10. So this is all we would see. 0, 2, 4, 6, 8. Let's verify. 0, 2, 4, 6, 8. And then in the loop. I neglected to mention that part. Okay, so we're repeating something multiple times. It really depends on what our variables are and how we're incrementing them and what the conditional is. One thing you definitely need to look out for is an infinite loop. This is something that is surprisingly common when you're learning, but also if you're just being lazy as a developer or if you're particularly tired or you're not paying attention. An infinite loop is when your loop never ends. So here, this will end. I is equal to 0. We're adding 2 as long as it's less than 10. So at some point, it's going to become more than 10. But what if I had messed this up and instead I did I minus equals 2? I'm not going to run this because my browser will get very angry with me. It's not the end of the world in your browser. Usually, at least in Chrome, my browser window gets a little bit, it freaks out. My computer gets hot. I close that window eventually, or Chrome will tell me something's going wrong and I can force quit it. It's not the end of the world, but it's annoying. I'm not going to do it. I will start at 0, and then we subtract 2. So it goes to -2, -4, and it's always less than 10. It will never be greater than 10 because we're always subtracting, starting from 0. Or another thing you might see is something like if you ever, I wouldn't do this, but if you ever wanted I to equal 10, and then let's say we started at 1, and we're adding 2 each time through. This is kind of a janky thing. I don't know why you would do this. I will start at 1. Then we add 2, so I becomes 3, and then we add 2 more, becomes 5, and then 7, then 9, and then 11. It skips over 10. We're never equal to 10. Anyway, it's kind of a janky thing, honestly. You probably would never do that. But that's the basic syntax of a for loop. It allows us to repeat something. So why don't we do something, it's not much more interesting, but let's do a little practice where we print out the squares, the perfect squares, which would be things like 1 times 1, and 2 times 2, and 3 times 3. So 1, 4, 9, and then we have 16, 25, and so on. We just create the numbers from 1. Let's go from 1 to 20, and print out each perfect square based off of those numbers. So I want to see 1 printed out, and then 4, and then I've already forgotten 9, 16, 25, all the way up to 400, which is 20 times 20. So we're going to use a for loop. I'll comment this one out. I think I'm actually just going to reset it back to the beginning for loop that we had. Just go with I++, so you have that available to you. And I'll comment it out. Now to create this for loop, we'll call this perfect squares 1 to 20. I'll add a little comment. We'll have a for let, it doesn't have to be I, but very common. And we'll start it at 1. We don't care about 0 times 0. We will keep running while I is less than or equal to 20, because I do want I to be 20. I could also say, well, I is less than 21, but I like less than or equal to 20. I++, we'll just add 1 to I each time. Okay, so I will be 1, add 1 each time, as long as I is less than or equal to 20. And we can always just check our work by just printing I first. Okay, there we go, 1 all the way down to 20. Now to get the perfect squares, I just multiply I times I. Refresh, and now we have 1 times 1, 2 times 2, 3 times 3, all the way up to 20 times 20, which is 400. So here's another little quiz or exercise. I'd like for you to print out the numbers from 50 down to 40 in reverse order. So 50, 49, 48, all the way down to 40. Okay, so give that a shot. You'll need a for loop. Same pattern, but different numbers. Here is the way I would do it. I'll comment this one out. Let's just do, I don't know, count down backwards, 50 to 40. For let I equals, and we're going to start at 50. And we're going to keep going as long as I is greater than, let's do greater than or equal to 40. Each time through, we will subtract 1, which could be minus equals 1 or I minus minus. It's the same shorthand, I++. It's not exactly the same, obviously, but it's the same pattern. This adds 1 to I, this subtracts 1, or decrements I. So we start at 50. We subtract 1 each time through. As long as I is less than or equal to 40, we keep running the loop. And let's just console.log I. Let's see if that works for us. So I'll refresh, and we get 50, 49, 48, all the way down to 40. Yay! Next up, we have another type of a loop called a while loop. So a while loop is relatively simple. The syntax is definitely shorter than a for loop. All that we do is pass in one condition into a set of parentheses. And as long as that condition is true, which we would call the test condition, as long as it's true, the loop continues to run. So it may not be a set number of times, like a for loop. We go from 1 to 10 or 50 to 30 or whatever it is. With a while loop, we could have something like while there are no new emails, or while our queue of jobs is empty, or whatever it is. We can have some condition that may not lend itself as much to a for loop. But we can also recreate exactly what we've already done using a while loop. So for example, over here, we're counting backwards. I could rewrite this as a while loop. It would look something like this, while. And we would need to initialize a variable first. Let I equals 50. And then while I is greater than or equal to 40, we will console.log I. And then we will I minus minus. So same principle. It's shorter here. It's easier to mess up if you're doing a while loop, because you have to remember to decrement. You have to make sure you're not causing an infinite loop. But this is basically the exact same thing. Let's just verify that. So while I is greater than or equal to 40, print it, subtract 1. Let's refresh our page here. And there we go. Our first batch goes from 50 to 40. That's the for loop. And then 50 to 40. That's the while loop. Now, where a while loop becomes more useful or more interesting is when you have something that maybe is not just a set of numbers or a sequence like what we have right here, but maybe we have a game and we want the game to continue while you have a number of lives. Number of lives is greater than 0. That might be an hour, it might be a decade, depending on how good you are at this game. Let's make a very simple, I wouldn't even call it a game. Let's make a password guesser. And to do this, I'm going to introduce a new built-in function you have not seen before. We've talked about console.log, which we can use to print something. Another thing that we have here is called alert, which is really annoying. Alert you call with parentheses, just like any other method we've seen. That will actually execute it. And whatever we put in here will actually be alerted to us in a little pop-up window. So this can be quite annoying if it's abused. And the other example, or the other method I'll show you, is called prompt. And prompt is going to accept some value here, like some sort of prompt, a string, like enter your name. And when we hit enter here, it pops up with a little window where we can actually type something in. Now we're not doing anything with it, but I could capture that. So I could do something like this. Let username equals prompt enter your name. So now whatever I enter in here, how about pizza face 1 2 3, if we look at username, it now has that value. And notice that it's in quotes, it's a string. It's going to stay a string. We can try and convert it. We haven't talked about that, and it's beyond the scope of this video. But if I did type in a number in there, like 2, and if we look at username, it's the string 2. Okay, so now that we have a way of getting user input, a very simple, primitive way. Typically, we would make a form with HTML and CSS and have some fancy layout, but prompt is a very easy way to get some tiny piece of information. Let's hop over here to our JavaScript file. And what I'd like to do is make a really, really simple demo with a while loop, where we're going to have some password you're trying to guess. Let password equals, and let's have it, what should we have it equal? Let's just set an initial password, a very simple one to remember, like LOL. Then we're going to have a user guess using prompt. So prompt, enter the password. And we'll save that to a variable, let guess equals prompt. And then I want to repeat this process. I want to keep asking for a new guess as long as the user has not correctly guessed password. So I can use a while loop. While guess is not equal to password. Keep running this code. So what do I want to do when guess is not equal to password? I want to get a new guess again. So we start with our password, it never changes, at least not while the code runs. Then we initialize guess based off of some input a user types thanks to prompt. And then we're going to check, is guess equal to password? If it is, then this never runs. But if they are not equal, then we get a new guess. And it runs again. Are they equal now? Nope. Get a new guess. And keep going until at the very end, we can add something in here like console.log, you got it right. So this will only run when this finishes. So let's see what it looks like. I'm going to refresh the page and enter the password. I'll enter in hello. Nope. Enter the password again. Nope. LOL. We made it. So what might be slightly nicer is to add a console.log in here. Console.log. Please try again. Something like that. Repeat this. Enter the password. No, please try again. Please try again. LOL. We got it right. So here's a situation where a for loop would not really work for us. We don't have something running a set number of times. It might happen the very first time. We might get password correct immediately, or it might happen after a million times or never. Hopefully that's not the case, but it's possible. So a for loop, like we have here, is really commonly used when there's some set number of iterations. You want something to run 10 times or 100 times or 5 times or whatever it is. A while loop can be used to do that, as we've seen here. We can use numbers and increment and decrement, but it's also commonly used when we have something that runs an undetermined number of times. Indeterminate? Undetermined? Anyway, so that's a while loop. The final loop that we'll take a look at for now is the for of loop. And this is a really commonly used newer way of looping. It's new-ish, which is why it does not work in Internet Explorer, unfortunately. It is a way of iterating over arrays and other iterable objects. We won't get into the exact meaning of that, iterable objects, but we can iterate over things like strings as well, using for of. So before we do anything with for of, let's talk about how we would iterate over an array. Suppose we had this array of purchases. Let's say this is, I don't know, we're traveling, and this is the purchases we've made recently, or whatever. It doesn't really matter. Let's just pretend it does make sense. It's an array of purchases. If I wanted to total them together, or even just print out each purchase, but that's kind of silly to print something to the console. But imagine I wanted to do something with it. I wanted to subtract it from a bank account, or I actually wanted to, if we had a payments platform we had built or that we were integrating with, I actually want to charge a user for each one of these. I need to actually send a request and bill them using Stripe or something. So I need to do that for each element in here. We could loop over using a for loop and generate an index, a number. So start with 0 and then go to 1 and then 2, then 3, then 4, then 5, then 6, then 7. So we could do a for loop like this. For let I equals 0. Well, I is less than purchases dot length, add 1 to I each time through. I could do this, console.log purchases of I. I'm just generating a number. I goes from 0 up until the last index in this array. Remember that the length is always one more, so we don't want less than or equal to, we want less than the length of an array. And we add 1 to our index. So let's see what we end up with. This should just print out each value. 1999 up to 285. How would I sum them all together? There's a simple, hopefully a simple exercise. How would I put them in a variable that had a total? Well, I would do something like this. Let total equals 0, and then inside of here, total plus equals purchases of I. Not I. Remember, I is the index. So we'd be summing 0 plus 1 plus 2 and so on. We want the actual element at that index. And then at the very end, why don't we console.log total is, and then we'll print out total. I could also use a string template literal if I prefer to do that. I could do this, total is, and then we need our $, curly braces, our total variable. And I'm actually going to put a second $sign there, which is kind of confusing. This one will show up as a $sign. You can see it's green here, not blue. So it will be there because it's a price I want to display. Let's see what we get. Oh, lovely. We're not going to go into rounding in JavaScript, so we'll just go with this many decimal points. So that is just great. But it seems correct, I think. 258. Is that, yeah, I guess we got about 200 there. Yeah. Anyway, so we're iterating over an array, but we're not doing it using a for of loop. We're making a regular for loop. We're generating an index. But there's an easier way, which looks like this. For some variable of some iterable, do something. So I could rewrite this, what I have right here. I'll keep the original and comment it out, and rewrite it down here using a for of loop. So for some variable, so we'll come back to that, we'll call it x of some iterable, which is going to be an array. So for x of purchases, instead of x, we need to come up with a variable name that makes sense. X would work, it's just not very logical, or, well, it doesn't make sense. Let's leave it at that. So whatever this variable is, it is not going to be an index. It's actually going to be each individual element. So I would go with purchase or price or item, transaction. I think, I don't know, purchase is kind of long for purchase of purchases, but I guess that's relatively clear. It's just kind of long to type. Inside of here, that variable, purchase, every time through the loop, we'll reference one of these elements, starting at 1999, then 950, all the way until the end, and then the loop will finish. So if I just print out purchase right there, I'm not going to print out the total, just comment that out. We should see the exact same thing, 1999 to 285. So we don't have to deal with an index. You don't have to deal with the length and starting at 0 and I++. We can, but if we just want the actual elements, a for of loop is very, very easy. Come up with some name here that's descriptive, some variable of some iterable. And then we can print out each thing, or we can do something to each one. So why don't we add it to total? Total plus equals purchase. And then we can print out our total down here. And hopefully we get the same exact total. And we do. Such a lovely number. Okay. We can also iterate over things that are not arrays. As I've mentioned very briefly, there are other iterable objects. We're not going to spend much time on this, but you could do something like this. For let character of some string. That string is something you can loop over. Let's console.log character. Run this again, and there you go. You can see each character printed out. Not that common to do, but it is something that you can. All right, so that's enough of looping for now. We've seen three main ways to loop. The first one is a for loop. The second one is a while loop. And the third one is a for of loop, which allows us to easily iterate over some array. Just remember, it does not work in Internet Explorer. So we've got one more big topic that we have to cover. This would be incomplete if we skipped functions. Functions are really at the core of JavaScript. They are probably the most important concept that you need to understand to be a competent JavaScript developer. Functions are really just reusable, I hate reading my slides like this, reusable procedures, but that's what they are. They are things, bits of code that have been wrapped up and given a name that we can then call again and again and again, some chunk of code that we can execute later. And we can also do things like pass in arguments. So as an example of why we might want a function, take a look at this code that we just wrote. Right, we have an array of purchases. We are totaling them all up by looping over and adding each purchase into a total variable, and then we print the total at the end. Now, what if I had another array of purchases for somebody else? Or this is an application, and I wanted to run this code every single time somebody added an item to their shopping cart. So if I wanted that to happen, let's say I just had a second array called purchases 2 or Tommy's purchases, I would have to repeat all of this code. And that would be really annoying. So that's where a function comes in. We could write a function called get total or calculate total, and we could pass in purchases and get the same end results by making this reusable modular function. So with functions, there are two steps. We define our function, and then we execute or we run the function. So we'll start by defining a very, very simple function. I'm going to comment this out. We'll start with a function called laugh, and all that it's going to do is console.log haha. So the simplest way to define a function is using the keyword function, and then a function name, which is usually it's just like a variable, camel-cased, except the first letter is lowercase. So in this case, if I just do laugh, it's all lowercase, but laugh loud would look like that. You can do whatever you want, but typically it's camel-cased. So function laugh, and then we have parentheses. And then we have curly braces. And inside of these curly braces, I'll write some code. So let's do a console.log ha 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 ha. And then maybe, how about he. I don't know. Is that how you spell he? And then let's do haha again. So just 3 lines, 3 useless console.logs. And I have written them inside of a function that I've named laugh. Okay. So if I run this code right now, where is it? Here it is. If I refresh, nothing happens. I don't see anything because I've only done the first step, which is defining my function. I now need to execute my function. And think of how we execute a method. So a method, like to uppercase or any of the array methods like push or pop, those are just functions. A method is a special type of a function, but they're functions. So we have to use parentheses to execute something like a string dot to uppercase. This is not going to work. I need parentheses to actually run it. Same thing here. I've defined laugh. Now I have to call it with those parentheses. So now if I refresh the page, there we go. Ha ha, he, ha 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 ha. I can laugh again and again and again. Okay. So that is the first thing to understand about functions. We define them, and then we call or we execute a function. Now, there are other syntaxes for how we define a function. Another option is called a function expression, where we can save a function in a variable. So we had laugh. What about laugh out loud will be another function. And this time is slightly different. I don't give this function itself a name. I'm storing it in a variable with a name. It's really nothing we need to care about at this point. Just worry about this syntax. But now that we're on this topic, another thing you might see are arrow functions. This is a newer feature in JavaScript, something that if you are serious about JavaScript, you definitely should consider learning. I have a pretty thorough video on that as well. But for now, we'll go with our standard function declaration, or function statement is what it's called. So function keyword, and then a function name, and then curly braces, some code inside. It will not be executed automatically. We have to manually call that function with parentheses. Okay, so the next thing we need to understand are arguments. Arguments is actually a term we've already talked about when we saw things like index of or push. For example, we have some array, const data equals an empty array, and then we call push. We need to pass in the thing that we want to be pushed onto that array. This string, in this case it's a string, is an argument. It is information we pass in inside of those parentheses to push. So if I wanted to make a function, I guess we could go with laugh, where instead of just ha ha ha, he, ha ha ha, every single time, maybe I want this, how about I want to specify how hard someone is laughing, so how many ha-has we get. So it might be something like this, ha-ha, or it might be ha-ha-ha-ha-ha-ha-ha. I want it to behave differently based off of an input. Well, the way that we accept an input is by adding a parameter right here inside of these parentheses on the function definition. Put something in here like, what should we go with? Level or loudness? Sure, loudness is fine. Now, loudness is going to be a variable that we have access to in here. I can console.log loudness, just like that. And let's see what happens right now. If I call laugh with no arguments passed in, what do you think loudness will be? Well, let's see. It is undefined. But now if I call laugh and I do pass something in like a string, I'm just going to put something random in there. That is loudness. Now if I pass in a number, there's our loudness once again. This is just a placeholder. It's just a name that we've made for the first thing that is passed in. So let's assume it's going to be a number. Like we're going to call laugh and pass in a number like 5. What I'm going to do is use the string method repeat, which we have seen before. If I do ha.repeat 5, we get ha 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 ha. I think I said it 5 times. And if I do it 10 times, we get ha 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 ha, and so on 10 times. So I'm going to use this loudness to indicate how many times, or to control how many times we repeat these characters. Now, loudness doesn't really make sense because it's really more the length or the duration. I don't know. Maybe I'll call this level, laugh level. Okay. Then here I'm just going to quickly replace this ha.repeat laugh level. Now, we do have to be careful with how we call this function, right? If I pass in something that's not a number, it could break things. But that's all. That's a bigger topic to figure out whose responsibility it is, really, to define a function that handles every possible screw up, or if it's on the person who's calling a function to recognize how it works. Anyway, let's just go with this, a single line. Ha.repeat laugh level. So now if I call laugh 5, we get that. I call laugh 10, we get that. And laugh 100, we get that. We have made a reusable chunk of code that is not only reusable, it's not the same thing every time. It also has some degree of flexibility where we can actually manipulate the behavior based off of a single input. And we can also have multiple arguments. So instead of just a laugh level, maybe we could also add in a name of the person who is laughing. So our console.log could be something like Connell says, ha 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 ha, or Marianne says ha, and that sort of thing. So laugh level, and then we'll have laugher, maybe just name. And I'm just going to start by printing out the name so you can see it. Name is name. And right now I'm just calling laugh with 5. What do you expect to happen? What will we see when this prints out and when this prints out? I'm just passing one thing in. Well, all that we see is name is undefined, but we still get our 5 ha's because it's all dependent upon order. So whatever we pass in first, it happens to be the only thing, will be assigned to the very first parameter here. So it's about order. It doesn't matter, if this was a name like Connell here, it's still going to be saved or stored in laugh level, which will probably break things. We'll see what happens here. Repeat is expecting a number. Okay, it just doesn't repeat it at all. It just gives us an empty string, it looks like. Just the equivalent of that. So now let's actually pass in a name as the second value and then laugh level as the first. And we should see name is Connell. Ha 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 ha. We got 9 repetitions of ha. So we can use that name now. I think what I would do is probably save this into a variable. Const, I don't know, probably just has. I guess that looks like has. What should we call that instead? Laughter? Sure. And then we can console.log. And then I'll use a string template literal to put the name in here. Name says, and then another embedded expression, $ curly sign, $ curly braces, laughter. Okay, let's see what happens. Refresh, and we get Connell says ha ha ha. Let's laugh again 4 times, and it will be Marianne. Marianne says ha 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 ha. And if I leave that off, undefined says ha 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 ha. So if we wanted to add in a default value, this is probably a bit more than we need to go, a bit more detail than we need for right now. But if we wanted to, we can use an equal sign here and then pass in some default in case there is no name specified. So name can be anonymous maybe, and laugh level can be, 1. So let's see what happens. Now if I call laugh with no arguments, anonymous says ha. But if I do pass in, how about 45? We get anonymous says, and then 45 repetitions. Okay, so that's the basic idea of arguments. It's all based upon the order that we pass arguments in. JavaScript doesn't care about the type, so even though we know in our hearts, we know that this should be a number, JavaScript is not going to stop us from passing in something that's not a number. It just might give us an error message. We might have something go wrong in the function, but there's nothing in place that says this has to be a number or this has to be a string. Now, the last concept we need to discuss around functions is returning values in the return statement. Right now, this function, every time I call it, is going to print something out, and we can actually see that here. Of course, we can see it here. I don't know why I said that. That was idiotic. We have been seeing it. It prints something out, but what is this undefined? Why does it keep showing me undefined? Well, let's compare it to something like pop. So we call some string, I don't know why I'm doing a string, it's an array. Let's have the array 123.pop. When I call that, I'm getting a number showing up down here. What this number is the return value. We've talked about this briefly. It's what the function, the method pop, gives me back. It's not the same as printing it. So if I wasn't doing this in the console and I pop something off, we won't see it in the console. If I just did it in a file over here, I have some array and I did pop, it's just gone unless I capture it in a variable. A return value is kind of what it sounds like. It's the thing that a function returns that we can then capture in a variable or pass to another function or reuse in some way. So let's write a function that does return something. Let's do something very simple. How about a square function? I know it's not very exciting. Square will accept a number. And if we call num of 4, we would expect it to return 16. We could begin by just printing out the square. So nice and easy, console.log. We could do num times num, or we could do num star star 2 to raise it to the second power. Sure. So right now, no return. I'm not writing the word return. I am just printing something. So when I call square of 7, we get 49 printed out, but then undefined is the return value. We did not define a return value. So printing something out, again, is something we do when we're starting out or we're debugging. You're watching a tutorial like this, but in the real world, we're not going to be console.logging very much at all. Like if you go to a website, right, you're not typically looking at the console to see something. So usually what we do is we would call square of 7 and then capture it somehow. Capture that return value in a variable or do something with it. I don't know why, append it over here, make a button with it. That seems silly to do with square of 7. But let's say we had a function called, get latest tweets or something. We might want to call that and then do something with the return value, the latest tweets. They might be in an array or something. So printing is very limited. It's not really what we want. All we need to do instead is use the return keyword and then return something. We could do this in one line like this, return num ** 2. If you prefer, you could make a variable first like const result equals that and then return result. It's kind of unnecessary here because this is nice and short. So I'll just do it in one line. Return num ** 2. Okay, so now if I call this function, I'll refresh the page. I already called it square of 7. I don't see anything here. It's just lost. That is how a return value works if you don't capture that return value, if you don't use it. So I could save it to a variable. Const, how about just result equals square of 7. I'll refresh. And if I type results in my console, you can see 49. So if I call square of 9, we get 81. Yes, it's showing up here, but it is not console.logged. So I could save that to a variable now. Const answer or AWS or ANS equals square of, how about the square of 13? We now have 169 stored in this variable. So the return keyword is how we can export a value, how we can ship something out of a function and capture it somewhere else. We also can do things like, what if we had a different function, a really simple one, but we'll call this add. Add will accept 2 nums. How about just x and y? And it will return x plus y. Nothing crazy. Just refresh over here. I'll show you how it works. Add 2, 5. We should get 7 returned. All right. So I can use one return value and pass that in to another function. So what if I did something like, how about add 1, maybe 5 and 7? That will give us, 12? And then I'm going to just take that directly and pass it in to square. So this is going to be evaluated first. 5 plus 7 should give us 12. And then that will be passed into square because it's returned from add. You can think of it as just replacing this right here. 12, square of 12 is 144, I think? Let's see. Just run it over here. Yes, there we go. All right, so some simple examples of return values and using the return keyword. One thing you definitely need to be aware of is that whenever you return something from a function, that function is done executing. So if we had something after this, console.log hi, that code is never, ever going to run. If I call square, you can see we never console.log hi. Return short circuits, it stops the execution of the function. Now, return has to actually run. So if we had a conditional in here, for example, if we didn't want to add negative or square negative numbers, we could do something like if, let's just say num is greater than 0, return num squared. Otherwise, down here, we can console.log not allowed. So this code will run in certain scenarios. What I'm trying to say is that just the keyword return on its own is not enough to just stop execution. This line actually has to be run. So if you pass in a negative number, this will not run in here, and this runs. I guess I should demonstrate that. If I call square of 1, it is returned 1 times 1. But if I do square of -2, we get not allowed. This line never was executed. Okay, so returning is a really important piece of functions. Really really important. We have inputs, which are arguments that we can pass in, like here, 7. And then we have our outputs from a function, which is really just one output, a single return value. Now, you cannot return more than one thing. You could return an array, you could return an object. If you had multiple values, you can combine them into one data structure, but you can't return like 5 different strings unless you combine them in some way into one entity. So that's returning. All right, so now what we're going to do is combine some of what we've seen, not every single piece, but some things, variables, conditionals, functions, return values, a couple other things, to make a very simple guessing game. Again, very, very simple, nothing crazy, not really anything you want to write home about. But the goal of this video is not to build something impressive, it's to get you just comfortable with the basics. This is a process. If you're legitimately just starting out and this is the first thing you're learning in JavaScript, or the first sort of taste of JavaScript, there's a lot more to JavaScript, and there's a lot more that goes into learning it. It takes time, it takes practice. So unfortunately, we can't build anything mind-blowing, but it's simple. It's better than nothing. So we get a prompt. Please guess a number. These numbers are between 1 and 10 for now, although you can change that. Let's guess 1. And you can see it tells me, this time I console.logged it, 1 is too low. So please guess another number. All right, let's try 9. 9 is too high. All right, how about 5? 5 is too low. Another thing I'll show you is that if I type something that is not a number, well, like a string here, text, please enter a valid number. I'll keep trying that. It keeps asking me to enter a valid number. Now let's try, let's see, 5 is too low, so maybe 8. 8 is too high. Okay, 7. I win. And that's it. So nothing crazy. But I will tell you in advance that I did use a lot of, not a lot, but a couple of functions to make this work. If you would like to try this on your own, definitely give it a shot. There are a couple of things that we have not covered in order to make this work. One of those issues that you'll run into is dealing with what happens if a user enters something that is not a number. They enter like that. How do you compare that? The other thing is generating a random integer from 1 to 10, but we'll go ahead and run through this together. Okay, so the first thing we want to do is pick the target number. We want to pick that initial number, and we've seen math.random, which gives us a random decimal from 0 to 1. It doesn't include 1, but 0.9 or whatever. So it gives us something like this. That would be one of the results that we get back. Now, what I'm trying to do is pick a random number from 1 to 10, an actual whole number, an integer. So without boring you too much, the stock way that you do this is using math.floor, which is another method on that math object. Math includes a whole bunch of these methods. Floor is going to take something that has a decimal and just chop it off. So math.floor of 23.999999 is just 23, or 23.0001, it's still just 23. Now, if we just floor math.random, we're always going to get 0, because math.random is between 0 and 1. But if I multiply this by 10, for example, now I'm taking some random decimal from 0 to 1, multiplying it by 10, and then chopping the decimal off. So we get 976, but we also get 0. So if I want this to go from 1 to 10, I also need to add 1 at the end. This is just a very common way of doing this. It's kind of annoying. Other languages have a simple way of doing this, like generate or random int. We don't have that in JavaScript. So we'll save that to a variable. Let's call it target or target num. Okay. And then we're going to ask a user to make a guess. So something like, how about just let guess equals prompt. Enter a number. All right. Now we have our first, well, there's a bunch of hurdles. One hurdle here is that prompt is going to be stored as a string, even if I enter a number. So if we look at guess, if I enter 8 here, and I look at guess, get rid of this, come on. It's the string 8. So I want to turn that into a number. And the way that I'm going to do that is using something we have not talked about called parseInt, where I can pass in like a number 8, and I get 8s, but I can pass in something like 30, the string, and get 30 out. If I have a decimal, it's just going to ignore it, which is fine because we're only dealing with integers. There are other ways of converting a string to a number. Parse int is simple enough for now. So we're going to call parse int. So let guess equals prompt, enter a number. We could just do parse int right here. We don't really ever care about the string version. We only want the number version. But what happens if we enter something in like parse int of hello? We get not a number. And if that's the case, if you remember from the demo I showed you, I wanted to prompt you again to enter in a value that is not a string or that is not invalid. Unfortunately, checking to see if something is not a number, it's not as simple as you might think. You might think you could do this, not a number, and just check is something equals not a number. This is always going to be false. It's a bigger topic I'm not going to go into now. It's a very weird quirk in JavaScript, but comparing not a number to another not a number will never give you the same. They'll never be the same. They're always different. So we have a method that we can use called number.isNotAnumber, and then we can pass in a value like guess. All right, so we're asking, please enter a number. We get a string. We turn that into a number, but if they entered something that's invalid, like hello or a space or whatever, we get not a number from parse int. So then here we can check if number.isNotAnumber of guess. Let's do it. Whoops. Let's do the same thing and update guess. Let's do it again. Okay, so let's try that. Enter a number. I'll enter in, I don't know, LOL. It says enter a number again. But that's still only going to run one time. And that could be problematic if I enter in something like LOL, and then it asks me again to do it, and this time I do LOL again. Now guess is still not a number. So I'm going to want to loop. I want to continue to loop while this is true, while number is not a number. So while your guess is not a number, I'm going to get a new guess. And I'll change this to be, please enter a valid number. All right, so now this should keep going as long as I enter something that is not a number. And then if I do, like 9, we're good to go. All right, so now we need to implement the basic logic of the game where we're going to check if your guess is equal to some target number that we've defined. Notice I used const here. This is not going to change in a given game. Guess is going to change. We've already seen that. So I used let. So we basically want to check if your guess is equal to the target number, but we don't want to do it one time. We want to continuously do it as long as they're not equal to one another. So we're going to have another while loop. And in fact, I'm just going to comment this out for a moment and just write our basic while loop. While guess is not equal to the target number, we're going to ask for a new guess. And if you remember what I showed you earlier, we also get we give the user some feedback. It says your guess is too high or your guess is too low. So we could do something in here like if guess is greater than target num, we'll console.log, and I'll do a string template literal that just shows the guess here is too high. So if your guess is greater than the target, we'll print whatever, 9 is too high. Else, we'll do the same thing except too low. Guess is too low. All right, so that's going to give some feedback, but we're going to have an infinite loop if I run this right away because I need to make sure we're getting a new guess every time through this loop and checking that each time. So I'm going to call this again. Please guess again. Enter a number. Sure, let's do please guess again. All right, so we've got our while loop. We start with our target num and with guess. And then while guess is not the same as target num, we give some feedback, too high or too low, and then we get a new guess. And if it's not correct, this process starts over. It runs over and over and over until guess is the same as target num, at which point we could do something like alert, you win. Sure. Let's see what happens here. Refresh the page, enter a number. Let's go with 9. 9 is too high. Please guess again. 1. 1 is too low. 2, 3, 4, 5, 6, and we won. Okay, so on the surface it may appear to be working, but we don't have this error handling. It's not even error handling, but we don't have this type checking here. We got rid of that. But what we want to do is make sure that we have that. And I've added it back in, but it's really only going to work the very first time you make a guess. So if I refresh the page again, let me finish this. Come on. Okay, here we go. So if I refresh the page again, I'll enter a invalid number. It scolds me. It asks me to enter a valid one. But now every other time, it's just saying not a number is too low. Not a number is too low. This logic went away. I want that to come back in there. I want to make sure that we're still checking to see if you're actually entering a number. So what I'm going to do is take this logic and also include it after you make a guess. While that guess is not a number, we're going to keep guessing. And that should do the trick for us. Let's see. 1, 9. I'll enter something invalid. Please enter a valid number. It's going to keep waiting and waiting for me to enter something valid until I do. So now we have our basic logic. Our code is kind of ugly, and I would like to clean it up using functions. So that's what I'm going to do. I'm just going to make a couple of functions and move this code into them. So the first thing I'll do is just take this entire thing and put it in a function called probably start game. And the only reason I'm doing that is just to, make things a little bit easier to understand. And then instead of start game, I think I'm going to, do I want to keep this here? Yeah, I think I'll just keep that there. I might make a function just for practice here, called generate random or something. You really don't need it, but just to get practice, down here I'll define generate random. And we'll return math.floor, blah, 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 blah. Okay. But then we have some seriously duplicated code. This right here, making a guess, or asking for a guess, making sure it's not a number over and over and over, and then the same thing here. So what I think I would do is actually make a function called, get input. And get input is going to prompt to enter a number, okay, and parse that int. So I'll just steal that from here and save that to a variable, let guess. And then we're going to continue to check while that guess is not a number, same thing we've already done. Please enter a valid number, all right. And then at the end, we're just going to return guess. So if we made it to this point in this function, it means that your guess is a valid number. It's not a number. Okay. Now I can actually replace all of this. I don't need this here anymore. Let guess equal get input. And that's it. I've moved that logic over there. And I can also do the same thing here. Guess equals, get rid of all that, get input again. So let's verify that it works so far and I haven't messed anything up. I will need to execute start game. So I'll just do that here at the bottom. Refresh the page. Enter a number, 1. 1 is too low. Let's try entering something in invalid. Please enter a valid number. So the same logic, it's just been moved around. So 9 is too high, 3, I won. All right. And I think that's pretty much all that we'll do for now. We could move this into its own function, this logic, to display whether your guess is too high or too low. Honestly, though, it's not really something that I wouldn't do it. It's just a couple of lines here that we'd be saving. It would be nice if we displayed something other than you win, maybe how many guesses it took. So that would be something definitely worth adding in. You guessed correctly on your first try, or it took 10 tries or whatever. Also, other things you could do is make it harder. So ask a user at the beginning, how hard they want it to be, how many, what the range is from 1 to 10 or 1 to 50 or 1 to 100. Also give the user the ability to quit at any point, because right now, if I start it over, I have no way of getting out of this. If I want to finish, I can click cancel, but it's just going to keep yelling at me. So maybe you could check to see if a user enters queue or quit, and you could stop the loop, which is actually not something we've covered. You need to use a keyword called break. Another thing that you could do if you wanted to add on to this is give the user the ability to replay or to start over once they win. So there's a lot of things here that you could add in, but honestly, I just wanted to do something slightly more complex than what we'd seen so far. Nothing crazy, and like I've said before, it takes time, it takes practice, and there's a lot more to JavaScript than what we've covered. There's no way, even in a couple of hours on YouTube, there's just no way that I can show you everything that you need. I'm a broken record, but my JavaScript courses are like 40 hours because there's just a lot to talk about. All right, thanks for watching, everyone. I hope you endured and then maybe enjoyed this. I know it's long. Trust me, it's long for me too. All right, it's a lot of work. Please consider subscribing, liking this video, sharing it with anyone who you think might be interested in learning JavaScript, especially if anyone has some spare time these days. Maybe it's a good thing to learn. And again, this video is sponsored by me, my online software engineering bootcamp, Come to the Job Guarantee. If you are serious about continuing to learn JavaScript and other things like React and Python and SQL and databases and Git and GitHub and Terminal and all these skills, and you want to leave with a nice portfolio of projects, take a look. Again, you're paired with a mentor, one-on-one. You meet every week. You can take this at your own pace. Finish it in 6 months, or do weekends and weeknights, finish it in 9 months. You get mock interviews, career support, and if you don't get a job, then you don't pay anything. So pretty low risk. Anyway, take a look, and thank you again for watching. I hope you're all doing well, and that's pretty much it for me. Oof. All right, goodbye.